This comprehensive C# course will take you from the basics of C# programming to advanced concepts, all while integrating exciting mini projects to solidify your learning. This course offers a structured path through essential topics such as syntax, object-oriented programming, data structures, and more. Abba teaches this course, and he will help you understand C# both theoretically and also gain practical experience in applying your knowledge to real-world scenarios.
Hey there, FreeCodeCamp, Abba here. Join me in walking you through everything you need to get set up with C#. Let's have a quick walk through the course content to let you know what's in store for you. We'll start with installing the Visual Studio program required to develop C# applications. You'll learn about data types including integers, strings, and many more, and how to manipulate them inside your code. Next, we'll dive into control flow. You'll discover how to use conditional statements and loops to control the flow of your program's execution. Strings are essential in many applications. You'll master powerful string functions in C#, allowing you to manipulate and transform text effortlessly. Data structures are crucial for organizing and managing data. From arrays to collections, you'll explore various data structures in C# and learn how to use them effectively. Functions are the backbone of any program. You'll uncover the power of functions in C#, including how to create and call them to organize your code. No program is immune to errors. You'll learn how to handle exceptions gracefully in C#, ensuring that your applications remain robust and reliable. Debugging is a crucial skill for any developer. You'll discover how to use Visual Studio's powerful debugging tools to identify and fix bugs in your C# code efficiently. Finally, we'll delve into object-oriented programming. You'll learn the principles of object-oriented programming, how to use classes, objects, inheritance, and polymorphism to create modular and maintainable code. By the end of this course, you'll have a solid understanding of C# programming and be well equipped to tackle a wide range of software development challenges. Thanks for tuning in, let's get started. So in order to start developing with C#, we need to install the latest version of Visual Studio. In this case, it's currently 2022. So let's head over to Google and type in Visual Studio 2022 download. We will be presented with two links. We have this one and this one. We want to use the second one which says download Visual Studio Tools. So if you press on that, and now we're presented with the download area. We have three editions: Community, Professional, Enterprise. Community is free for students, open source contributors, and individuals, which is exactly what we need for the content of this course. We have the Professional Enterprise Edition, which are paid for and only used by bigger companies or smaller teams. So let's go ahead and press free download. The download will start straight away. After the download is complete, let's start the installer. So double click on the executable and press yes to allow it for admin permissions. It'll pop up like this: Visual Studio Installer. Before you get started, we need to set up a few things so you can configure your installation. You can read the privacy policy in the software terms if you'd like, or you can just press continue. So it's getting the Visual Studio installer ready. So when you get to this section, everything here is all the different packages and tools you can install within Visual Studio 2022. The main one that we're concerned with in the contents of this course is the .NET desktop environment, so you can go ahead and press this one. It will then tell you in the bottom right hand corner the total space required is 6.52 gigabytes. Please make sure you have enough storage space available for this, and then you can go ahead and press install. If you want to check out other packages, you can have a scroll through and read any other packages you may need and may want to install. Like I said, the only one required for this course is the .NET desktop environment. You can also deal with Node.js development, Python development, web development. If you need to deal with individual components like specific versions, you can access it here. If you need some more languages installed, you can access it here. This should automatically select your default language for you that's based on your system's language. And if you wanted to, you can also change the installation location in case you want to install it on a different drive or you just want it in a different folder. So now that we've selected the .NET desktop environment, we can go ahead and press the installation button. We do have two options down here. We have an install while downloading and a download all then install. If you have a reasonably fast computer, you can stick with the install while downloading and it will do the installation and the downloading at the same time. If you have a slow computer, it's preferred that you use this option to download it first and then install. It just means that it won't slow down your computer too much. So you can go for this one and press install. Now the installation will begin. So now that Visual Studio is finished installing, it will say done installing, Visual Studio has been successfully installed. We recommend rebooting soon to clean up any remaining files. So this just means restarting your computer just so it has a chance to clean up any files that were kept during the installation process. So we can just press OK. If you have any other versions of Visual Studio installed, they'll also show up down here. And now that Visual Studio Community 2022 is installed, we can just press launch. So now it will prompt you to sign into Visual Studio. We should definitely sign in, but just for now I'm going to skip, but feel free to create an account or sign in if you already have one existing. We can skip this and then we get to choose your theme. I personally prefer the dark theme, but you can go with blue, blue extra contrast, or the light mode. So let's select dark and hit start Visual Studio. It will do a first time setup, and it's already done, and we're already inside Visual Studio 2022. So that's it for the Visual Studio installation. So now that we got Visual Studio 2022 installed, let's see how to create your first project. So once you've opened Visual Studio 2022, you'll see this window popping up. You can clone a repository from things like GitHub and Azure DevOps, or open a project that you already have, or open a folder which may have projects inside, or you can create one from scratch. If you don't want to do any of these options, you can just open the Visual Studio program just on its own by clicking Continue Without Code. So let's go down the Create a Project path. So click on Create a New Project, and we'll get a list of all these different projects inside our system to be able to use. The ones we're going to be focusing on this course is going to be C# in the languages drop-down box, and the platform is going to be Windows, and the project type is going to be console. And they have one that uses .NET Core, which is for Linux, Mac and Windows, and one that uses the .NET Framework, which is Windows. So we want to go for this one. So press on this one and then press Next. Here we have our project name, our location and our console app. So we can start with the project name and say, My First Project. And as you can see, it'll start copying it over to the solution name as well, and it tells you where the project will be created into. So it'll be creating a folder called My First Project, which is the solution name, plus My First Project, which is the project name inside that folder. If we change the solution name, you'll see it update. You can see here now we have multiple T's because we appended the solution name. The solution name is almost like a folder that holds lots of projects inside. So to begin with, we'll have one solution that has one project inside, and then later on in the course, if you feel like you want to add more projects to it, you can just add more to this solution. So let's get started and press Create. So now we've created our very first project. And just to explain what's here, we have a static main void, which is the main entry point to our program. If you do a lowercase m, then the system's not going to recognize this main function because the .NET Framework requires this function to be found in order to run a C# console app. And you can see here in the errors, the program does not contain a static main function, and you can see it's capital M. And C# programming language is case sensitive, so make sure to include it. So now you understand how to use Visual Studio 2022 to create a project and also know where the main entry point is in C#, let's get started with a Hello World example to kick off this course. So as we know, our main entry point to our application is the static void main. If we go inside here and press enter, then we can actually start writing some code inside here. Just a quick note before we continue. Static void main is inside the class program, and the class program is inside the namespace hello world. And the reason why you can tell this is because of the curly braces. The curly braces of hello world begins here and ends here. And within these curly braces, we have a class program, and also within the class program, we have the static void main. So just between these curly braces, we want to type console.writeLine, open the brackets, and we can type in some speech marks, and we can simply type hello world. There you go. So as you can see now, system has actually been highlighted. So if we just delete this line, you can see now system has been grayed out. And the reason why is it says it's unnecessary because it hasn't been used. So if we undo it, then this comes up. Because I showed you before that console WriteLine is actually within the system library, what happens if we delete it? If we delete it, then it doesn't know where console exists from. And because that just said system, we can actually just use system.console.WriteLine and then open the brackets and type in hello world. And now this works again. And the reason why this works is because we don't have to define that we're using system, we could just use it straight in here. If you have multiple lines like this, then you don't want to be using system right at the start. Ideally, you want to have the reference to it at the top of the screen and then use it throughout. So now that we've included it back in the project, you can see that now these have turned gray and it says that it can be simplified. If we press the little light bulb, and we can say simplify member, and it doesn't really matter because we can just delete the rest now. So now that we've wrote hello world, let's press F5, which is a shortcut to the start button. As you can see, Well, you couldn't really see because the program closed too quickly. And the reason for that is printed hello world to the console and then it didn't do anything else because there's nothing else for it to do, so the console simply closed. We can use another command called console readline, open the brackets and close the brackets and have a semicolon at the end. All this does is it waits here until the user inputs something, reads the next line of characters from the standard input stream. So although the program will actually be reading stuff, we just want this line to stop the application from closing. So now if we press F5 and run the program, you can see it actually says hello world and it's just waiting here flashing. And this flashing means it just started this console read line. So it doesn't matter what we type into here, it just waits for us to press enter. And as soon as we press enter, this line executes and the program finishes. Congratulations, you just wrote your first C# program. Welcome to the amazing journey of programming. So let's look at how to make variables in our C# code. Let's start every code with a console read line, and then we can hit F5 just to make sure our console doesn't close. So let's begin with an integer. So integers are whole numbers. So we can just say int age equals 23. So what we've actually done here is we've said we want an int, we want to call it age, already made it equal to 23. This is called initializing and declaring in the same line. So what you could do alternatively is you can end the semicolon here and it just says int age. And then on the next line you can write age equals 23. So this is declaring it in the first line and then give it an initial value in the second line. If they're right underneath each other like this case, then you may as well just make it together because then you have less lines of code. The reason why it says it's a green underline is because there's an unnecessary assignment because we're not actually using age. So let's just print age to the console. If we make some new lines and we can type in console.writeLine and then press tab to finish it, we can write age. And if we run our code using F5, we can see that 23 gets printed out to the screen. So now that we've worked on the age, let's explore other data types. So let's define a long variable. So let's start with the type, long, followed by a space, and then the variable name that we want. And let's add an equals and type in a very big number. So now if we hover over it, it says it's a system int32. And the int32 is actually an integer, but we're telling it it's a long, which makes no sense. We have an int64 here, but when we hover over the number, it comes up as int32. And the reason for that is, when C# sees that you just have a number typed in like this, it will always assume that it is an integer. To tell the compiler that you indeed want this to be processed as a long number, then you can put a capital L right at the end. Now if we hover over it, it says an int64, and this says int64. So now we've got it working, and we've got the long there. So now we can take another console write line and just print this out to the screen. And just a helpful tip, if you type in CW and press tab twice, then you get the console write line. It's very easy to write your code, and then you can type in big followed by a tab and it'll come up straight away. So as you can see, they're both being printed to the console now. So now that we've made positive numbers, we can also make these negative by simply just putting a negative sign behind them. There we go. And just to show you how big these numbers are, what we can do, we can type in int.maxValue and then make another one using Ctrl-D and type in int.minValue. So you can see integers can be positive 2.1 billion or negative 2.1 billion. And if we do the same for long, you can see that long is a very, very big number because instead of being an int32, it's an int64, which takes up a lot more memory. So now we've covered whole numbers, let's have a look at decimals. So we can have a double negative, for example, and we can say it's minus 55.2. And in this case, when you just have a number typed in like this, and it's got a decimal point in it, it will always register it as a double. But just to make sure, just as we're doing with the long, you can actually just put a capital D at the end. Now if we print this out to the screen, and also print out how big these numbers can be, max value and min value, and print this out. So we get our minus 55.2, and you can see that these numbers can be very big. E plus 308 means it's this number times by 10 to the power of 308, which is a very big number. And we also have that as a negative. So we have float, let's call this precision, and make it equal 5.00001, and then put a semicolon at the end. Now we've got a problem here. This is trying to register as a double, but we don't want to register as a double, we want to register as a float. And this is the same issue we had with long. So when you type any number that has a decimal point in it, the C# compiler will always register as a double. The same way when you type in a whole number, it will always register it as an int. So in this case, we need to put a capital F at the end, and it will process this as a float. So now we can print this out. And then let's just print out the max values and the min values just to show you what that looks like. So as you can see here, we have our number printed out. And again, we have quite a big number, 3.4 times by 10 to the power of 38. So again, it's a big number, and we have that positive and negative. So quite a big range of numbers. And the last one we're going to cover is decimal for things like money and currency, 14.99. And again, in this case, it's trying to assign a double into a decimal. So in order to denote what a decimal is, you can put a capital M right at the end. And for one last time, let's print out the money and the decimal dot max value, Control D, and then we'll do min value. And you can see here that this is a really big number as well, and it's even bigger than the long. So we have our number printed and the max and the minimum values. So now that we've understood that how to declare a variable, I have an extra little tip for you. So if we had three variables, int x, an int y, and an int z, and let's say you're always going to declare them together like this, you can actually miss out and do x, y, z, and that will do exactly the same thing. There we go. And that's really neat, and it's a lot better. But let's say, for example, you had these variables, but you actually had them set to something like equals 10, equals 20, equals 30. This is still practical, but it might look a little uglier. So you can actually type them in straight into here. And if you comment these out again, then it still works. You can even put these onto new lines like this, just so it looks a bit neater. It just prevents you from typing the additional int each time if they're all going to be the same variable type. So that's it for the numbers inside our code. So let's just have a quick recap. So in order to define a variable, you want to use the data type, in this case an integer, followed by the variable name, and then you can either add a semicolon at that point, or you can add an equals to give it a value. This is just called declaring a value, and this is called initializing a value. If you want to decide you want to change the variable further down your program, for example age equals 50 here, then this is fine, and this is now called an assignment. It's called initialization because as soon as you make it, you give it a value, and then later on in the code, if you give it another value, this is called simply assigning a value. This is just called assigning it a value. So now that we can store numbers in C#, let's see how we can store characters and letters. So as you know from the introduction, we have a string variable. So let's call that name and make it equal to ABBA. Please note that when you're defining a string and giving it a value, that this value needs to be in speech marks. If you put it in quotation marks, it will not accept this, because that's the notation to declare a char, which we'll get onto next. So on the next line, we can do a char letter equals, and we can't have something like this, because the char will only accept one singular character. So we have to wrap it around the quotation mark. Once you've wrapped it around the quotation mark, then it will accept it. So let's print these two to the screen. So CW tab tab, and we can just print these to the screen. And if we just run the code, you can see that we've got the values entered in here. And we can start to write stuff. Your name is, and then we can output this, and we can also put it on one line. If we do a console write and a console write, then maybe we can take the colon off and just have it a space, and we can say your name is ABBA. And we're seeing that additional A because that's the right line for the letter. So we can space it out with an empty console write line, and they'll add a gap between them both. There we go. So now we know how to declare a string variable and give it a value, and we can declare a char variable and also give it a value. Just a quick recap, when you're declaring and initializing string variables, you need to put the value in speech marks, but when you're declaring and initializing a char, you don't have to put it in speech marks, you put them in apostrophes. Whenever you see apostrophes, that can only ever refer to one singular character. When you see a speech mark, it could be one or more characters. Also, things can be empty. This just means the string is empty. This is also a valid character, it just means that we're storing a string but it has no value. With a char, that's not exactly the same. You can't store an empty character literal, it has to be given something. Chars get defaulted at \0, which is just the default character. But don't worry about that too much now, we'll go into escape characters, which is the / later on in the course. For now, just note that whenever you declare a string variable, we need to put it in the speech marks, and when we're declaring a char variable, we need the quotation mark. So now that we know how to define numbers in C# and to also define strings and characters, then let's look at how to convert between them both. So let's take some similar code from our first video, and we can define an age, the number, the negative, the precision, and the money, and we give it the same values from the first video. We simply just print them out to the console here, and if we just run, we can see them all. But this doesn't help us because we're just statically typing in the numbers. What if these were actually processed as string and we want to convert them into an int? So just above each of the variables, we're going to make another variable. So we can say a string text age equals -23. And then for the age, what we're going to use is this function called convert to int32, and we can put in the string inside the brackets. And what this is now saying is we're taking our string text age, which is equal to -23, and we're passing it into this function convert to int32. And the reason why it's int32 is because an int is by definition an int32, which is a 32-bit signed integer. So what we want to do here is convert for our text age into an int32 and store it back into our int, and hopefully we should see the same value when we hit run. 23. So now that's actually went from a string variable and then went into our integer, and we've printed it out as an integer and it's no longer a string variable. Now we can do the same for the other ones. So we can have a string text big number and make it equal to this value just in the quotation marks. Now we're typing this value in the quotation marks, we don't need to put the L at the end. The L is just to tell the compiler that we want to use int64. If we take the L away, then it's going to think it wants int32. This is not really applicable when it comes to text, because we're going to explicitly say on the next line, we want to convert to int64, so the compiler already knows that it's int64, and we don't need to put an L at the end. Now let's make sure this works, and there we go. So what we should end up with is the console should look exactly the same as how we had it at the start of the video, but actually what we're doing is converting it from a string into the applicable value. String text negative equals -55.2, and then in here we can do a convert to double. Add the text negative inside here, and let's just run it to check. And we still have the same value, so it's going well. We have a string text precision. Make it equal to this. And then instead of this, we can have a convert to, in this case, it's actually going to be a single. And the reason why it's a single, when you hover over float, the definition for a float is indeed a single. So we can add that in, text precision, and we're just going to do the last one and just check it all together. Text money equals 14.99. And then instead of this, we can have a convert. And let's have a look at this. A decimal is indeed a decimal. So we can say 2 decimal and then add the text money in. Perfect. So now if we run the line of code, we can see that all of these values are exactly as we had them. Now they're being represented by their official descriptions based on a string conversion. As I mentioned before in the error video, the problem you'll have with this is if this value actually has a character inside, you will get a runtime error. This can be fixed in the future when we look at how to resolve these errors, and we can have exception handling and use functions like try pass so we can try and avoid these exceptions occurring. Because when these exceptions occur, the rest of our code does not run and it becomes fatal at this point. But for now, don't worry about this too much. Just get used to the notation and how these things work. So this video, we're going to focus on the Boolean data type. So we can make a Boolean data type by saying bool value equals true. This Boolean value is literally just a true or false value. We can store anything in here, and maybe something like bool is male, and we can just say true. And later on in our code, Booleans are used to make decisions. We'll cover this in the next section of this course, but booleans are mainly used for making decisions. If one thing is equal to another thing, then we can take another path, or if something is true or something is false, then we can do another path. Like for example, if you make an output to the user, you could check if this value is true, and if the value is true, then you can address the user as a male, and if the value is false, then you can address the user as a female. These are the kind of things that booleans can help us with. And just like any variable, if you want to assign it later on, you can just assign it again. And if we print these out to the screen, just like that, you'll just see the values true and the values false appear on the screen. As of right now in the course, there's not a whole lot to do with booleans, just understand that they can hold a true or false value. So now that we know how to define different variables and how to convert between them, let's see how we can perform operations on different data types. Let's say we could have an int age equals 23. And then what we can do to that age is we can say age plus plus. And what this age will do is it will actually just increment age by 1. And if we do age minus minus, it will decrement it by 1. So if we just print it out after, and after this as well, what we'll notice is there'll be no change because it'll go forward 1 and then back 1. There we go. We went from 23 plus plus to 24 and then minus minus to 23. That's one of the important operators that you'll see a lot, especially during the next section of this course. So another way to be able to add 1 to a variable or anything to a variable, we can replace this with age equals age plus 1. And what we're saying here, we want age to have the value of itself added to 1, which will give us the same result as doing age plus plus. Another way of writing this as a quick shorthand is you can say age plus equals 1. These three things are doing exactly the same thing. When you do an age plus plus, you can only increment by 1 and only 1. These two options give you the flexibility of having something like 10. These two are doing exactly the same. Age equals age plus 10, and this is going to read exactly the same thing. It's just when you use plus equals, it will take the value of the current variable and add it to 10, which is exactly what this line does. To make it a lot shorter, you can use age plus equals and then just put the value at the end, just in case you forget to mention age twice. So now if we just get rid of these two lines of code, and we can just have a look and see if this runs. So now the value should be 33. Perfect. And now, as we said, we're going to cover plus, minus, times, and divide. So just as you did with plus equals, you can actually do a minus equals as well, which will give us 13, and you can do a times equals, which should give us 230. Now, if we try to do divide equals, we're going to run into an issue. It says 2. 23 divided by 10 is 2.3. And when you take 2.3 and make it into an integer, it's just going to truncate the 0.3 and leave you with 2. With integers, if you add two integers or take away two integers or times them, you'll always end up with an integer. If you divide two integers, you don't know what you'll end with. For example, if you make this into 20, then you'll always end up with 2. But that's not always the case. As you just saw, 23 divided by 10 is 2.3. So if you're ever going to do any division, it's best to actually make this a double. Because now that we do the division, we actually get 2.3, which is technically the right value. So you can add, minus, times, and divide any variables that you want. These are just demonstrated in int and double, but you can do this with the float, the decimal, etc. So let's have a look and see what the plus and the minus operators do when you've got a string variable. So we can have a string name equals Abba. And then we can say the name plus equals is programming. And then we can just print out name to the screen and see what happens. So there you go, you've actually just joined two strings together. They're completely separate from each other and we've made them string together. So if we try to do a minus equals, you can't really remove from a string because a string is just text. It'll be very difficult for the compiler and for the C# language to be able to determine what's currently in the string and whether you can remove it or not. This is not something that's built into the language. So let's remove that and we can have the same thing with a char. Now the problem with the char is if we add A to B, then let's see what happens to the output. What it will try and do is actually get the Unicode values for both of these items and try and add them together as integer variables. So when you add A and B, it will take the Unicode value and you will actually get a capital A with a squiggle at the top. And if we open character map, you can see that this squiggle at the top is right here. A, which is Unicode 61, and 61 actually means 97 because it's 6 times by 16 plus the 1. And B means it's 6 times 16, which is 96 plus the 2. So you have 97 and 98. And if you add them two values together, you'll get the hex code, which is C3, just for this character. So what you're doing is you're kind of adding them both together and you're producing weird results. So unless you really want to do this, then you should be wary about adding two characters together. One more thing to note about when you're doing plus plus, so let's bring another int variable back, and we just say int I equals 0, and then we can do I plus plus, and then if we print out I, the value should be 1, which is fine. What if we did I plus plus, but we did plus plus I? So the value is still going to be 1. But what happens if we put this I plus plus straight into these brackets? Let's try and run it, and you still get the value as 0. That's strange because we've said I plus plus. And what happens when you do plus plus at the front? It will actually execute this and return the value of I and then do the plus plus. So if you actually print the value of I after, you'll realize that now it becomes 1 after. If you ever had a situation where you need to increment first and then use the value, you can use plus plus I. And now if we run it, you should see the value is 1 twice. The difference is that as the plus plus is before the variable name, it tells the compiler, please do this action first and then return back the I. If you don't want that behavior, then use I plus plus. Finding the remainder between the division of two integer variables can be very handy when you're determining whether a number is even or odd. Let's look at an example. Let's have an int first num, assign the value of 10, and int second num and give it the value of 3. Now if we just print to the screen first num divided by second num, what do you think you'll get? So the value of this in the calculator will be 3.3 reoccurring. So we'd actually just get 3 because it's truncating it because of the integer. So now what happens if we need the remainder between both of these? You could actually work this out by seeing how many times that 3 would be divided by 10 as close as possible, and you'll see is the value is 3, and then 3 times by 3 is 9, which will give you 1 left over for the 10. But that's a bit too long in our code, so we have something called a modulus operator. So we can actually change this divide for a percentage sign. And what this will output is it will only give us the remainder. So let's say 10 divided by 3 is 3.3. As we've just said, but the remainder is different. Remainder is exactly how you learnt it at school. 10 divided by 3 is actually 3 remainder 1, because 3 times 3 is 9, and then you have 1 left over to get to 10. So that'll be 3 times 3, which is equal to 9, and then 1 left over to get to 10. So now let's run our code and see if we do actually get 1. There we go. So the best way to determine if a value is actually odd or even is to divide it by 2. So we can say 10 modulus 2, and if the value is 0, then that means the value for first num is actually even. If the value is 1, then it's odd. And let's see how this works out. If we had 10 modulus 2, then the value is 0, because 10 can be divisible by 2 perfectly. Let's say we had 11 modulus 2. The closest multiple to 11 is 10, which is 5, and then we have 1 left over. So you just have the remainder is equal to 1. And if we just keep going up in the chain, we'll realize that it's the same pattern. Every single time you go up a value, the value just toggles. So when we print this out to the console, and the value is actually 0, that means the number is even. And if we make the number odd on purpose, and then rerun the code, you can see that it's a number 1 now, which means this value is now odd. So let's look at a couple of examples and see if you can figure out the answer. If we do 1000 modulus 90, what do you think the value will be? And let's write a couple more. If we do 100 modulus 90, and maybe something like 71 modulus 10. So have a think about this in your head and see if you can figure out the answers. Pause the video and see if you were correct. Let's take a look at the answers. So we can see we have 10, 10, and 1. So the closest multiple to 1000 from 90 is 990. So we have 10 left over to get to 1000. And the same goes here. The closest multiple of 100 to 90 is just indeed 90. So we only have 10 to get from 90 to 100. And in this case, the closest multiple of 71 to 10 is 70. And we have 1 to get up to 71. Therefore, these two answers are indeed correct. So now that we know how to really define a variable by specifying their type followed by their name and giving it a value, let's see how we can do a very easy way of defining a variable. So normally we would type int age, but we can use this var keyword. And what this means is the compiler will figure out what type it needs to be based on the value we initialize it with. So if we just make a variable called age, then it's not going to like it because you need to give it a value. This doesn't give the compiler enough information to figure out what this variable is going to be. Just because it says age, this is just text to the compiler. This does not mean anything. So if we make it equal to 23, then the compiler can see that this is indeed int 32 because it knows that. So now if you hover over var, it says int 32. Now let's try and do this for the big number. Var big number equals 90,000. And what will happen now is because it's defined as int 32, it's going to say this is int 32 as well. And this is the same issue we had when we were first defining the long variable in the first video. We need to explicitly give it an L just so this knows that it's int64, and now the var has updated to an int64. Instead of rewriting each one, we can just change these to var and inspect what happens. Double, double, and now we have a float, single, single, and finally the decimal. We have a decimal, and we have a decimal. And the same thing goes for a string. We can say var name equals ABBA, and we can have a var letter equals A. There we go. And they'll both register as their applicable data types as a string and as a char. And if we just print this out to the screen to make sure everything's working fine and run the code, you can see that everything is exactly how we'd expect. So just a quick recap. You don't have to do this. At the end of the day, this will be exactly the same as writing this, because when our code gets compiled down, it doesn't matter what these things are because the compiler will deal with it however way it wants to. This is just for us to read it. In some cases, if the value is very obvious, like as we know, an age cannot really be a point. 23.1 years old. No one says that in real life when you get asked your age, so we can just assume that this value is going to be an integer. And that's fine because that's an easy number. That's an easy example. But if we say we want a negative or a big number, then it doesn't really tell us what we're meant to be. Like this big number could be somewhere up to 2.1 billion, which is what an integer supports. But in this case, if it's going to be a big number and we specify the L, then we're going to need a really big number, bigger than 2.1 billion. So in my honest opinion, it'd be very beneficial to only use var if it's very obvious what the variable is going to be and what it's being assigned to. Using var too much might hurt the readability of your code in the future, because you'll have to inspect each variable individually to read what the type is going to be. If you're scrolling through your code and you can see that this is long very quickly and you don't have to hover over it, then it can improve your read time. This is really important as readability of code will make more sense when it comes to big projects. When you have 20-30 lines just like this project, then it makes almost no difference because it only takes a couple of seconds. When you have big functions and big software, when you work at a job, then it's going to be very difficult to be able to find your way around and to understand what's going on, especially if you're new to the code. Something very simple like this, where you know you're defining a name, it's very obvious and var will be accepted. Fine, because you can tell that this is always going to be a string. There's no other data type in C# gets specified by a speech mark. Whereas when you're defining numbers, it can be very, very hard to understand what different data types that people are using throughout the code. Especially when these numbers are not statically typed in, they might be inputs from the console, from the user, from a different function, from anywhere. So having good variable names along with their explicit types will be very handy to understand code in the future. So now that you've understood how to make a variable, let's look at a concept called constants. So if we defined a variable called VAT and we set it to 20, just to represent the 20% VAT in the UK. Now later on in the program, we can actually change it to anything we want. And that's because it's a variable. Variables can change. In certain circumstances like VAT, you might not want to change it and you want to disable the ability to change it out the code if it's done accidentally. Let's say for example you're making a banking application and you wanted to fix the VAT. and you don't want anyone else to change it. You can add this keyword called const right before the declaration. And now when you go to reassign it, you'll get an error message. And it says at the left hand side of the assignment, so anything before the equal sign has to be a variable, property, or indexer. And in this case, if you hover over VAT, it states that it's a local constant. Local because there's no access modifier before it, and constant because we specified the const keyword. So now if we try and run the code, we'll actually get a compile error because the VAT cannot be changed. So if we remove that and then we just print it out to the console using seg1FirstChapter, and then we can put VAT in the brackets and press F5. And now we can see our 20 being printed. So let's try and calculate some values using this code. If you have an int balance, make it equal to 1000, and let's say we wanted to calculate the VAT based off this. Then you'd have to do a little bit of a complicated calculation. You have to take the balance, and because the VAT is a percentage, we need to convert it from decimal to percentage. So if we do times and then open the parentheses, we can insert VAT divided by 100. And just to make sure that this gets processed as a double, we want to write 100D because right now it's in 32. And if we leave this as an integer division, then we'll lose any decimal places, and decimal places are very important when it comes to percentages. So we put 100D at the end. Now you can see it says double, so it'll actually calculate as if it was a decimal number. So now if we print that to the screen, so we can see here that 20% of the balance is indeed 200. Instead of having to do this calculation each time, what we can actually do is make another const, this time making it a double because we're not sure what the output of this division will be and we don't want to truncate it, so we want it as a double, and we can say %VAT. And what we can do here when we assign the value, just because it's a constant, it means that we can't change the value. But that also means we can read it as many times as we want. So we can say the percentage VAT is actually the current VAT that we've got, specified here, divided by 100D. This will give us the VAT from a number form into a decimal form. So now when we do this calculation, if we duplicate this line using Ctrl D, we can remove these entire brackets and literally replace it with percentage VAT, and you should see we get the same values. Perfect. This can be very helpful in the future if you have things like version numbers in your code, and you can have version 1.0, and then if you ever specify this version later on in your code, you can just change it once up here and it will change the rest. This can be very helpful. You'll avoid a lot of typos and you won't have to redeclare this value several times. If you had 3 different occasions where you were displaying the version number in your code, then it's going to be problematic once you update the version number and you have to change every single occurrence and you might miss them. So inserting it once and only having to change it once is the preferred option. Just to note with constants, when you compile your code, all the constants will actually do is do a find and replace, so it will take this VAT and find all references of VAT and just drop the 20 in there. So this is more of a feature for maintaining your code from a user and programmer's perspective rather than anything to do with the compiler, because when it compiles, it just removes all the constant anyway, and then you're left over with the literal values that we've gave it. Nonetheless, this is still something very handy to learn and to use throughout your code. First, you want to define a variable to hold your name. So we can just say string name equals ABBA. Perfect, so that's the first one achieved. It says define a variable to hold your phone number. So at first, this could be quite easy. We could say int number equals, and then we can start to type our number in here. So now that's our number completed, let's move on to holding your age, and we can just have an int age equals 23. Print variables line by line to the screen, so we can use seg1FirstChapter and type in name, and then we can use Ctrl D to copy and paste the line, then we can do number, Ctrl D again, and then we can use age. Now if we run the code, let's see what happens. Here we've actually hit a slight problem. It says 1, 2, 3, 4 for the number, but I'm pretty sure that I started it off with 0. This is a problem with storing your number as an integer. As a number, zeros at the front don't really matter. If we had 100 zeros here, then it's not going to change the actual value. The only time zeros matter is if it's throughout the number or towards the end. That actually changes the number. But if we have lots of zeros at the start, then it doesn't change anything. So what you actually want to do in order to store a number is you want to store it as a string. Therefore, when you run the code, it will actually retain the 0 that we typed in. So now that we've accomplished all of these, let's see how we can define the variables using the var keyword. So if we hover over these, you can see that it's picking up that it's a string and a string here, and finally this is an integer. So what we can do, very simply, is just change these to var, and then let's hover over the variables and just see if the tooltip reads the correct data type. String, string, and integer. And if you run the code, you should see no difference. So in this exercise, I want you to create and initialize two integer variables, make a variable to work out the remainder, output the remainder to the screen, and then change the first integer variable to another number, recalculate the remainder, and output the new remainder to the screen. So let's take this step by step. So first we need to create and initialize two ints. Let's say int num1 equals to 10, int num2 equals to 2. Make a variable to work out the remainder, so we can have an int remainder equals 2, and if you remember how to do the remainder, it uses the modulo symbol, which is the percentage sign. So we can say num1 percentage num2. Now it says output remainder to the screen, so we can use seg1FirstChapter, add remainder in, and hit run. And just for now, we can see that the remainder is indeed 0. If the remainder is 0, then that means 10 is even, because 10 modulus 2 gives us 0, and if it's 0, then that means it's even. If the remainder was 1, then it would mean it's odd, so if we try 11 remainder 2, we get 1, so 11 is indeed an odd number. So let's change this back to 10, and then it says change the first int variable to another number, so just after here we could say num1 equals 11, and then recalculate the remainder, so we essentially just need to do this section again. We don't need to write int before these two variables, because int is only used when you're declaring it. This is reassigning the variable. So we'll reassign variable num1 to 11, and then we reassign the remainder to the calculation again. And now we can use the exact same line of code above to print out the remainder to the screen. Now you can see that it's 0 and 1. It's 0 because 10 is even, and it's 1 because 11 is odd. So far throughout the course, we've been using console writeline to output stuff to the screen. For example, I can output hello, my name is Abba, and we can see it in the console. The issue is, so far, we haven't really wrote any code to be able to read in values from the console. So let's explore that option right now. So in the console library, we have a console writeline. But what you don't realize is we can also use this console writeline to ask the user a question and to let the user type something in. So let's use seg1FirstChapter and say enter your name with a colon and then end the quotation marks. And then in order to return a value from the console into your program, we need to use console.readline. And if you hover over readline, let's have a read at the description. Reads the next line of characters from the standard input stream. Perfect, this is exactly what we want to do. Right now it's used at the end of our code just to stop the console from closing so we can actually see the output. So if we just run this right now, we actually get the opportunity to type, but when we press enter, our program closes. This is because in this case, we're simply using readline just to wait until the user has pressed enter so our program doesn't close. But what you don't actually see is this is returning as a string, which means that anything that we type into here, and when we press enter, it actually gets returned back to the code, but we're not doing anything with it because we don't care at this point. So now let's actually do something that will make us care about the user's input. So we can make a new string variable and assign it to console readline, and it should give us the ability to store whatever gets entered inside the console. So we can just do string name, and we can end the semicolon here, and if you wanted to, on the next line, you could do name equals console.readline. Or if you wanted to have it all in one line, then you can get rid of the semicolon and bring it up like this. This is the preferred method, as both lines were on top of each other and it wasn't really necessary to split them. Here we're doing a declaration of string name and an initialization and giving it the value of console.readline. And this is whatever value the user is going to type in. So let's run our code and see what happens. Enter your name, Abba. Now when I press enter, it's successfully stored Abba inside this string name variable, and now it's waiting at this line, the console read line, just right here, so when I press enter, the program closes. So now that we've made a variable and not done anything with it, let's print it out to the screen to make sure that something's actually worked. So if we use seg1FirstChapter and we type in name in the brackets, and we can run this code again, and let's see what happens. As soon as I type in ABBA and press enter, then this second ABBA is actually the variable printing out to the screen. So here it says enter your name with a colon, and normally when you see the colon, it sometimes lets you type on the same line. So if you'd prefer the user to type on the same line, then we actually have another function for that. Instead of using write line, we can just use write. And the difference between write line and write is the write line will actually have a terminator at the end of the line to tell the console that it wants to push everything after it onto the next line, whereas console.write will just print it out to the screen and not worry about any new lines. Let's try run it now. And now we can type in ABBA. As you can see, it's a little close to the colon, so we can fix that in a second. So if you press enter, you can see now that ABBA comes up on the second line. So if you just put a space after the colon just to give it a bit of room. Now if we type in ABBA, you can see that there's a bit of a gap and it's quite nicer to look at. Now if we press enter, you can see that ABBA has been stored successfully. So what we can do now is maybe ask for your age. So we can have a console.write, enter your age, colon space, and then do a string age equals console.readline, and then we can have a age output as well. And let's see how that works. So we can say ABBA, then say 23 and press enter. And now we have ABBA stored within the name variable and have 23 stored within the age variable. So let's try and output a string that's a bit more meaningful to the user. Let's clean this console up and see what we can do. So we don't need to output their result back to the console because they literally just type that in. And we don't want to have this line because we just use that as an example. So if we run the code right now, it'll look better. But it does look a lot more structured. Enter your name and then enter your age. So now when we press enter, the program will just close. So let's try and output these two variables in a formatted fashion. So as you now know, we can use console.write to print a lot of stuff on one line. So we can use console.write and we can say your name is, and then add a space and finish that line there, and then duplicate it down. We can write name, duplicate that down and say space and your age is, duplicate that one down, and then we can type in age. And let's see what happens now. ABBA 23. There we go. So we actually have the name output and the age output all on one line. If we all change these to write lines, then they're going to be on separate lines and it's not going to look very nice. So I'm just going to introduce you to a notation called string concatenation. This is the notion of being able to concatenate two different strings, which just means to add one string onto another. As you can see, this is taking up 4 lines of code and it's getting a bit ugly. The better and easier way to do this is by containing it all within one line. So we can have a console write line, and we can take the first section, your name is, keep the space at the end, we can end the speech marks and put a plus, and then we can say name. So now we've just added these two together. If we just comment out the rest of them and run the code, and you can see that they should be on one line. There you go. So we can say your name is ABBA, and let's just keep chaining the plus symbol. So we can say and your age is, another space, end the speech marks, and plus the age. Now we've got all of this contained within one line and it looks a lot better. Enter your name ABBA, enter your age 23, and now you can see exactly the same output but reduced to one line. As you can see, these 3 lines are all stuck to each other. So if you wanted to add a blank line between these two, you can just put an empty console write line just in here. And what this will do is simply just print the write line character to the screen, which will force the console to make it on the next line. Just like so. Here's the console write line from the empty line that we just wrote, and this is the console write line to output the values. So now that you've understood how to read values in from the console, let's try and convert some values. As I showed you how to do earlier on in the course, you can actually convert these strings into integers. Ideally, you want to store variables in their data types. As we covered before, ages should not be stored as strings, they should be stored as integers. But if you try and change this to an int, then you're going to have an issue. Console readline will return back a string, so therefore it can't implicitly convert from a string to an integer. So we need to do this in 2 steps. We can rename this to age input, and then on the line underneath it, we can say int age equals convert to int32, and then add age input in these brackets. There we go. And now when we actually print the line of code, nothing should actually change. Your name is Abba and your age is 23. But now what's actually changed is we're storing the variables in the correct format. This is the ideal method because in the next section when we cover if statements, you'll realize why this is very important. If you wanted to minimize the amount of steps you need to convert this, then you can actually move the console read line and get rid of the string input variable, and we can just paste it straight into the bracket of the convert to int32. And you can get rid of the string input variable and everything will work the same. Abba 23, and now it's working exactly the same. If this is too many steps for you or if this looks too complicated, then just please revert it back just to keep it the same way for the time being. So now we've learned how to read in values from the console and output them back to the screen. Now let's see how we can use if statements to divert our code into multiple paths. So in the previous section, I told you that it is very crucial for our code to have this int age. And the reason why is age is meant to be stored as a number and not as a string. So we read it in first as a string and then convert it to an integer using this function and store it into our age variable. This is the reason why. So our condition goes as follows. We write the word if, and between the brackets, this needs to be evaluated to either a true or false value. And then we can have the curly braces to tell us what to do if this becomes true. So in this case, you want to just check if our age input is greater than or equal to 18. Let's say this was an entrance to a place that only allowed over 18s to enter. So we can do age input, which references the age input variable, and we can use the operators equals, greater than or equal to, less than or equal to, or not equal to. So these are all the different options that we have. We can say if the age input is equal to 18. Perfect. So now that we've read in the age input, we can check if it's 18. Let's just process a message in here that says, you are 18. And let's have a look and see if this works. Abba, 18. Now I press enter, it says you are 18. But this is the problem with storing everything as a string and then trying to use it as if it was a number. If I type in 18 followed by a space, as you can see there's a blank space here now and press enter, you can see that it doesn't come up. And the reason why is it's processing it like this, with a space at the end. In order to avoid situations like this is why we would convert it to a number. And the reason why we're using equals to here is we can't use greater than or equal to because strings can't be greater than or equal to another string. They can only ever be equal to or not equal to. String is just text. So if something equals to something, then it's fine. The only way that we can use these different operators is if we actually interact with our integer variable. Now let's see how we can use this. So we can say age equals 18, and now you can see we actually reference it as a number. Now let's run the code. If I do 18 followed by a space, it still works. And the reason why is it actually dismisses that space when it's converting it to the integer. So now our age is stored as an integer and we can actually manipulate this a bit better. So instead of saying you are 18, we can say you are 18 or older. And now instead of doing equal to, we can have greater than. If we have greater than, then we're actually dismissing the number 18. Because if the age is greater than 18, so this will read like this. And 18 is not greater than 18, so this will return back false. What we actually want to use is greater than or equal to. If the age that we've inputted is greater than or equal to 18, then you are 18, hence the equal to, or greater than if you're older. So now let's try and run this. Abba 23. Perfect. You are 18 or older. Let's change some other if statements to add some additional conditions. So we can say else if, and the only reason why it would come into this bracket, if this condition returns false, it will move down the next condition in the else chain. If this was wrote as a separate if statement, then this would run completely independently from this one. If you're going to have chained if statements, you need to make sure that you chain them correctly. In this case, I want to check if it ages between 18 and 25, and then move on to a different age bracket. And these two things are grouped together, so we should have this as an else if. Because with an age bracket, you can only be part of one age bracket and not multiple. So we can say if age is greater than or equal to 25. And we can copy this and we can say you are 25 or older. Now let's see what happens. enter your name, Abba, and let's just say that I am 35. It says you are 18 or older, but I told it the program I was 35. Now the problem we're facing is any value that's over 18 will always enter inside here, and it will skip over this one completely. This is not the behavior that we want. So what we can do in our if statements is we can use the double pipe, which represents or the double ampersand, which represents and we can change some conditions in here to make sure that you implement some sort of range. So we can actually have a range between 18 and 25. So we can say if the age is greater than or equal to 18 and the age is less than or equal to 25, and we can tweak this message. You are between 18 and 25. And let's just run that for now and see what happens. Abba 25. Now it says 18 and 25. So now that we've got between 18 and 25 here, we can tweak this to be greater than or equal to 26. If you're 25, we'll enter this condition, and if you're 26 or older, enter this condition. So let's test that now. If we enter 35, now it says you're 26 or older. That's perfect because now that we've implemented range checking, it gives us the ability to differentiate between different age groups more precisely. Let's show an example of how to use the OR. So if we just have a block comment around all of this, we can write an if statement in here, and we can say if the age is smaller than 0 or the age is bigger than 150, then we can output to the screen invalid age. And what this is saying is if we're less than 0, and notice that this is less than 0, so this value will actually start at -1 and this value start at 150. Is -1 or less or over 150, then this will happen. Notice why it's an OR. One of these need to be true in order for this to be true. When you've got an AND, both sides need to be true in order for this condition to evaluate as true. So let's try our code. We can say Abba, and we put -1. And now it says invalid age, which is perfect because this is our range checking. And we can try again with 151. As it's just outside the range, it will say invalid age. And if we have an else on here, we can print valid age. Notice there is no condition in here. If you have an open else like this, it means if this were to return false, it will always do this regardless of any condition. In this case, it's perfectly reasonable to do this because we know that any values that are underneath 0 or over 150 is invalid, and anything between 0 and 150 is indeed valid. What you can do instead is actually move these if statements inside here, so instead of just printing out valid age, we can actually check the age as well. So let's run this now, and we can say Abba -1, and it will only print out invalid age and then move on, because once it reads this line of code, it will actually skip over the else and finish up down here. And now if you enter a real value, you are between 18 and 25. So let's follow the path. It got to here and realized that the range check was actually correct. So it jumped out of this curly brace and went to the else. Because this had returned false, we jump into this else and now we start checking. If age is between 18 and 25, which it was because our age variable is 23, then it outputted this to the screen. Now if we do the same thing but have 35 instead, then it follows the exact same path, except towards here, this will return back false, and then it will check the next condition. If age is over 26, then we'll return this. So now let's just make a quick multiplication program using if statements to see if you can get the answer correct. So let's just comment everything out, and we'll start the next section underneath. So let's make a console.write and ask the user to enter the first number. And then we can say int number a equals convert to int32, and the value that we want to convert is the console.readline, which is whatever the user's entered from the console. Again, if you're unfamiliar with this format, you can just type it in manually, number a input equals console readline, and then we can put the number input in here. Now if you use shift and highlight these lines and press Ctrl D, we can duplicate this entire section, and we can say enter the second number, change A to B, change A to B, and then finally change A to B. Perfect, so now we've got enter the first number and enter the second number, and we can say our answer equal to number A multiplied by number B. And then we can have a console.write value of, we can add to it number A plus an X plus number B, and then finally plus a colon for the user to type in. And then we can say string answer input equals console.readline, and then int actual answer equals convert to int32, and then we can have the input in here. So now that we've got one number from the console, the second number from the console, we're just making a variable that will multiply them together and store it inside answer. And then we're just going to ask the user what's the value of number A times by number B, and they can input that. We store it as a string and then convert it to an integer and store the answer into actual answer. So now just after this section, we can write an if statement that says if the answer equals to the actual answer, then we can say well done and else. And the reason why we don't need to condition this else, because with equals to, the only opposite thing you can have is if it's not equal to. So if you really wanted to, you could also write if answer is not equal to actual answer, then in here you can say close, but it was wrong. You don't actually need this. This is just for learning purposes, because this will return back false if they're not equal to each other. So this statement is just a given. If they're not equal to each other, then we can just assume that they're not equal to each other. So we don't need this additional statement. If this condition evaluates to being false, then that means they're not equal to each other. We don't need this additional check to check if they're not equal to each other, because that's a given if this returns back false. So we can just leave this as an else. Let's try run the code. 10, 10, value of 10 times 10, 100. Now it says well done. And let's just try that again, and we can enter a different value, 90, close, but it was wrong. So let's just have a quick recap. So in the previous section, we talked about how to input from the console, and we generated this line of code, which will output your name and your age in one line to the console. And then we looked at how we can use these different operators in our if statements, and we did some range checking to check if the age was between 18 and 25, and it would output something to the screen. And if it was over 26, you'd get a different output to the screen. And then we took that a little bit further and started using the OR operator. If the age is smaller than 0, or it's greater than 150, then it must be invalid. And if this condition returns false, it must be between 0 and 150. So we can come into this else bracket, and inside here we can do our range checking from the previous bit of code. We can check the ranges between 18 and 25 and print a value, or if it's over 26, we can print another value. And you can keep changing these if you want. You can have 26 to 40 and 40 to 60, etc, etc. That's up to you. So this is just a quick little program to simulate a multiplication program. We can enter the first number using console.write, and then we store it as a string, and we put that string into the convert to int32 function to give us back an integer variable. And we do exactly the same thing for the second number, and then we make a variable to store both numbers multiplied by each other. We ask the user what is the value of number A times by number B, and we give them an opportunity to type in a value. We read that value in, convert it to an integer, store it as into actual answer, and then in our if statement we say if the answer is equal to the actual answer, then we print well done to the screen. Double equals are used for equality, and single equals are used for assignment. Don't get them mixed up. We don't need an else condition in here, because if this returns true, then this will execute. If this is indeed false, that they're not equal to each other, then we always want to do this section, and we don't need to put an additional if statement inside here. If you wanted to, but it's not necessary, you can have else if answer is not equal to actual answer. But this is just extra code, and it hurts the readability, and it should be avoided. If statements are one of the methods we can decide different paths in our code. The next method we can use is called switch statements. So let's write a little program so we can demonstrate this. So we can just have a console.write, enter date of the week. And we can have int date equals convert to int32, and we can place our console.readline inside the brackets. So we take whatever the user's typed into the console and then place it inside here. And inside here, we're going to convert whatever they've typed in to an integer 32 and store it into our day variable. So if we just print this out to the screen to make sure it's working fine, if we just type in 7, we can see that 7 is returned, so it's all working. So normally what we do is type if day equals 1, and then we can add the curly braces and use CW tab, and we can print out Monday. Now if we run the code and try use number 1, then Monday works. And that's fine. And then let's do another else if, and we can say day equals 2, and then we can print Tuesday. Perfect. So if we try that now, there we go. So now we have the ability to print out Monday and Tuesday to the console, depending on what day of the week the user enters. But since we're going to have 7 different paths because we got 7 days of the week, then sometimes it might be better and cleaner to use a switch statement. So let's have a look at the syntax. So we can type in switch, and then inside the brackets is what variable we want to have a switch on. So in this case, we want to be using the day variable. So we can add day in the brackets. This is not a condition in the brackets. This is just telling us what variable we're going to be using for the switch statement. So let's open the curly braces after. And inside here, instead of having paths like this, we're going to use cases. So this can be translated to, in the case of number 1, we can do this. In the case of number 2, we can do this. So let's try and see how it works. We can type in case, followed by number 1, and then add a colon, and then we can type out our Monday in here. And then we need to follow each case off by finishing the section off with a break. This break's very essential, and you'll get a syntax error if you don't put it in. So now if we do case 2, and we do exactly the same thing, there we go. And if I dismiss the break, then you'll realize that it says it cannot fall out, so we have to use a break, just so the compiler knows that we want to break here. The reason why this break is placed inside here is because what we can do is we can say case 2, and then add another one in here called case 3. And what this now reads is if we enter 2, it says Tuesday, and if we enter 3, it also says Tuesday. So what you can do is you can actually chain. So this would be equivalent to writing if day equals 2 or day equals 3. Now this is exact translation. These two are exactly the same as of right now. We have day equals 1, which is our case 1, and then equals 2 or equals 3 is right here. If we go into the case 2 path, it will fall in the case 3. So we're saying for this break is we want to end this section here. So now if we just revert this back and continue the chain, I'll just skip this part just so it's a little bit quicker. There we go. So now that we've got all 7 days of the week, let's just see if it works. Let's try 6 and we have Saturday. So now we're kind of missing something from here. The only thing we're missing is having our external else, just in case the user types something invalid. So normally we would write something like this, enter a value between 1 and 7, just to make sure that the user knows what they're doing. Now we don't seem to have anything inside here that gives us the opportunity to it invalid. So we have this keyword called default, and it works exactly the same as the case, except what this will do is this is basically the word that replaces else. So we can literally take this line of code and place it again over here and add ourselves a break. This is exactly the same as doing our else statement inside here. If none of these cases match this variable, then it will go into the default and continue as normal. So if we type in 0, we should see the message twice because it's executing for the if statement and executing down here. And let's do 8 and you see the message again. So now that the case statement is fully working, let's just comment out the if statement and make sure that it still works. 1, Monday. Let's just try another one and we can do 7 for Sunday. So just a quick recap. Case statements are used by using the keyword switch followed by the variable in question. And then if you want to check if this variable number is equal to something, you put that something straight after the word case, followed by a colon, and then you can insert multiple lines of code inside here and make sure you end that line with a break. If you want to chain multiple like day equals 2 or day equals 3, then you can add the case above right here. So the case of 0 or the case of 2, it will do this little section. So it'll print out Tuesday if the user enters 0 or the user enters 2. Of course, in this case, we don't actually want that. After you've filled out all of the code, make sure you add something called the default. The default is equivalent to an else keyword in our if statement, just to catch all the values in case the users type something incorrect and you want to let them know what they should be typing instead. So now that we've explored different paths in our code using if statements and switch statements, Let's have a look at how we can iterate through our code. An iteration in code is just the ability to be able to loop and do a certain task. So let's say we wanted to print hi to the console several times. Then we just have to copy and paste it down, and this will be 5 separate lines that do exactly the same thing. This will essentially achieve what we want. The problem is, you just have exactly the same code copy and pasted. So what we can do, if we just block comment this line for the time being, we can write something called a for loop. A for loop gives us the ability to loop a certain amount of times depending on the parameters that we give it. So this is the syntax. You can type for, open the brackets, and we have to use a variable. So we can declare a new variable straight into these brackets. We can say int I equals 0, and then have a semicolon. And there's 3 different sections to this. The first one is the variable declaration and initialization, and the second one is the condition. So in this case, we want to do this task 5 times, so you want to say I is less than 5. Then we end that semicolon there, and now for the third task. Every time this for loop goes around, we want to increase I by 1 because we want to go in steps of 1. So we can do I plus plus. Alternatively, if you don't like using plus plus, you can say I equals I plus 1. Or to make that quicker, you could say I plus equals 1. I personally just prefer using plus plus, and you'll see that everywhere else. There are certain cases where you would actually want to change this to a different value, like I plus equals 2, and we'll show you that in a second. So this for loop now says, we want to go from I equals 0, and once this condition returns back false, when I is equal to 5 or greater, then we want to stop this for loop. Every time this for loop goes around, so when it hits this curly brace and comes back around, we want to do this action, and in this case it's I plus plus. So if we just use console writeLine and print out the value I, we can see what happens when the for loop runs. You can see that the value of I is increasing 1 each time, and after the 5th time is increased, the value is actually 5, so now this statement is false because the value of I is equal to 5, so therefore this is now false and the for loop is ended. So now that we've verified that you can repeat it 5 times using this code, we no longer want to print I, we want to print our hi. So let's paste that inside the bracket and run the code. Now you can see that these 2 values will be exactly the same as printing it out to the console just like this, but now we have a lot less code. So let's have a look at another example. We can say for int I equals 0, and we can say I is less than or equal to 10, and then we can do I plus equals 2, and then if we just print I to the console. So what this is now saying is I want to go from 0 all the way till 10, and I want to go up 2 times each time. So what this will be achieving is printing out all of the even numbers between 0 and 10. Let's try and run it. Now we can see we have all the even numbers printed out between 0 and 10 because we're going up in 2s. If we start this at 1, for example, and still keep every parameter exactly the same, then we'll be getting all of the even numbers between 1 and 10. 11 is missing because our condition stops at less than or equal to 10. What you can also do with for loops is you can let the user determine what this value is going to be. Let's test that. So if we block comment this section out, what we can do is we can append this little section. So we can have a console.write, how many times do you want to say hi? We can have a colon followed by speech marks, and then we can say int loop counter equals convert to int32, and we can have console readline inside the brackets. How many times you want to say hi, the user types in the value. We take the console readline as a string, convert it to an integer, and store it inside loop counter. So now what needs to change inside here? The 5 is what determines how many times that we're going to loop. So in this case, we actually want to just loop by whatever the user types in the counter. Let's just type 5 and make sure it works. And if we just type 1, it works. If we type 0, however, it will just skip over the for loop. And the reason for that is if you're going from 0 to I is less than 0, then this is immediately going to be false. So then the for loop is just going to get skipped immediately. There is nothing to do if the user's typed in 0, which is perfectly reasonable. And you can type in a really big number like 100 and it will output them all to the screen. If the user types in 0, then nothing's going to come up. So you always want to be able to let the user know if there's something wrong. So we can say if the loop counter equals to 0, or maybe we can change this to less than or equal to, because it could type in minus numbers as well. We could just say a console writeLine using seg1FirstChapter, sorry, please enter a value above 0. And then if this condition has returned back false, then inside our else statement, we don't need to give it an else if, because if it's less than or equal to 0, then we want to process the other values because it has to be greater or equal to 1. So when this is false, this section has to be greater than or equal to 1. So we can just place our for loop inside here, and that's fine. And let's try to run the code now, and if we type in 0, please enter a value above 0, and if we just try any negative values, we'll get the same message. If you want to print additional code in here, you can literally do anything you want. You can even ask the user what they want to print up here, and then you can replace this with a message. For example, we could have a string message, and we can just change this to hello world, and this could be something that you read in from the console. So we can say a message, and we can put that in here, and if we print that, there we go. So we can just say console.write, what do you want to repeat? And then we can read this in. And actually it might be easier if we change this loop counter to second. So if you highlight the section, hold Alt and press down arrow twice, we can move it down and say, and how many times do you want to repeat it? There we go. So now what we can do is we can use this message inside here and then loop depending on how many times the user's typed in whatever. So we can type in hello world and get this exact value, and we can say 10 times. There we go. So now this entire program is fully customized by the user's input. So let's just have a quick recap. So we started off this code by printing the console write line 5 times to the screen. We wrote our simple for loop that went from int I equals 0 to I is less than 5, and we did I++ because we want to count up in ones. You can place the high inside here and it will print it 5 times for us. So now we've made our code from 5 lines down to just 3 lines for the for loop. And then we allowed the user to type in how many times that they want to repeat it, and we changed the condition from I is less than 5 to I is less than whatever the user has typed in and stored within the loop counter. And then we hit a problem where if we entered 0 or anything less than 0, the for loop would just not run and it might look like some things went wrong. So we added a little if statement in here to make sure that the user has entered a value above 0, and if they haven't, we can let them know. We don't need another if statement in here because if this has returned back false, we can assume that the value is something that we can work with. We later tailored the program so we can change this message that was fixed to high to something that the user can type in manually. So now that we know how to use for loops, let's have a look at while loops. For loops and while loops still iterate through code, but they're used in slightly different contexts. For loops are used mainly when you know how many times you can iterate through, as in this example we're going to print to the console exactly 10 times. But in a while loop you might print until a condition is true. For example, if you are asking the user to type a number and they kept typing in something else, you don't know how many times it's going to take the user to type it in correctly, so in that case you would use a while loop. If you are executing a certain amount of code and you're only doing it a fixed amount of times, then it's always best to use a for loop. So first let's try and convert this simple for loop that just prints I to the console 10 times. Just like so, from 0 all the way till 9. So let's comment out this for loop and have a look at this syntax for the while loop. So we can type the word while, and then in here we have our condition, and then we can open our curly braces. And while this condition returns back true, it will always go inside the curly braces, and when this condition returns back false, then we'll exit the while loop. So let's try and mimic exactly what we're doing inside here. There's 3 sections to the for loop. We define the variable that we're going to use for the for loop counter, and we give it an initial value. We give it the stopping condition, and we give it how many times the value needs to go up every time the for loop iterates. In the while loop situation, we only have the condition available. So let's take our condition and paste it straight into here. And now we need to store our variable. So just because it's a while loop, when we can't store it inside here, we have to do it outside the while loop. So let's make it int I and we'll make it equal to 0. So we've got our variable, we've got our condition, and now we need to set I++. So inside the while loop, we can say I++, and then now we've achieved this entire line and successfully converted it. Let's try and put the console write line in and see what happens. And let's run the code. So it's going from 1 all the way till 10. And the reason why it's going from 1 till 10, not from 0 to 10, is because the I++ is at the start. Let's move it down one line using Alt and down arrow key to move it down, and let's run it again, and you can see it goes from 0 till 9. And if we just block comment this out and undo the for loop, you can see that they're doing exactly the same thing. So let's bring the while loop back. And as you can see, what we have is we've defined our I variable, made it equals to 0. While the I variable is less than the value of 10, we print the I to the console and increment I by 1, and we keep looping this until this statement returns back false, and then we exit the while loop and jump underneath the curly braces and hit the console read line. And this is the output that we've got. So now I've just copied the code from the if statement video, and let's make this code a little bit better. So let's comment out our while loop and our for loop that was just used for explanation purposes, and this is the code that you saw earlier on in the course. We read in the first number, store it as a string, use that string to convert to an integer, store number A, and then store number B, and these two blocks are exactly the same, except you have enter first number and enter second number, and we store number A and store number B. Then we store the value of them both multiplied inside our int answer variable. Then we ask the user what's the value of both answers times together, give them a chance to input their value, convert it to an integer, and then we check the value and print well done, or close but it was wrong. Now if we run this code again, and we type in 10 and 10, and we know the value is 100, but let's just type in 90. Now this is kind of a problematic user case. We've asked the user to type in a value and they've got it wrong, and then when they press enter, the program just closes. There's no opportunity to loop or try this again. So what we can do is add a while loop in here, and we can say, while the answer is incorrect, we can keep asking the user to keep on guessing. So instead of reading the input here, let's turn this little section into a question. What's the value of number A times number B? And instead of allowing an input here, let's just put a question mark. And then let's add a console write line just to give a little bit of a gap. And then in order to do our while loop, we actually want to create a Boolean variable just to track if the answer has been correct or not. This is the section that we want to loop around in the while loop. We want to read in the user's answer, check it, output a message, and then give them the opportunity to read in another value so they can guess again. While the answer is not equal to the actual answer, then we can loop around our code. So we have to modify a few things here. So we can't just take this code and place it inside. The problem with doing this is the variables that we want to check, answer is outside of this while loop, but actual answer is inside. And the reason why there's a red line here says it does not exist in the current context, because we're trying to check a variable that hasn't been defined yet. So what we can do is check the declaration for the actual answer and place it outside here and make it equal to 0. And instead of redeclaring it inside the while loop, we can take this int and get rid of it. So we set the actual answers to 0, set the answer to the multiplication. While the answer is not equal to the actual answer, then we want to loop around. So we don't actually need another check in here. This while loop will keep on repeating if the answer is incorrect, so we don't need a path for correct and incorrect. If this while loop still continues, then the answer will always be incorrect. So what we can do to double check is we can say, if the answer does not equal the actual answer, then we can place this message inside here and get rid of this branch. And then after the while loop has continued, we can say well done. So let's just read through the code. While the answer is not equal to the actual answer, and when this while loop first enters, it's going to be true, because you're going to have 10 times 10, which is 100, and the value of answer is 0, so this will return back true because these two values are not equal to each other. Then we're going to ask the user to enter the value, then we're going to read it into the actual answer, check if they're not equal to each other, and then we output a message. Because we're asking a question here, we want to ask another one using a console write line, enter your answer, colon. There we go. So let's have a look and see how this works. 100, 100. What's the value of 100 times 100? And let's just get it wrong on purpose. 90, close but it was wrong, and now we get to answer it again. And we can keep answering this as many times as we want until we reach the correct answer, which in this case is 10,000, and we've got the answer of well done. So to make the console look a little bit better, because this is all in one block, we can separate these with console write lines. Maybe after this line, we can print out a new line, and then after each guess, we can print out another new line. So after each guess will be down here, we can just print out a blank console write line. And just after you ask them to enter the second number, we can print another one here, and let's just see how that looks. 10, 10. Now it looks a lot better, because you ask the user to input the numbers, then you ask them the question, and then you get the answer, and then it keeps looping around like this. So there's a little gap between each one, so you can efficiently read it instead of it all being closed off together. And now if you answer it correctly, 100, now it says well done, and when we press enter again, the program now closes. So that was using a while loop, and now we have something else called a do while. And a do while is very close to a while, except that the while will only happen if this condition returns back true, and a do while will always happen once, and it'll check the condition at the end. So let's have a look and see how this works. So we write the word do, and then we have the curly braces, and then after it we have our while condition, and let's just copy the condition from the old while loop. And we can say answer is not equal to actual answer. So as you can see with a while loop, it will always check the condition first, and then it opens the curly braces. In the do, there is no condition, it will always do everything inside the curly braces once, and then it will check this while condition. If this condition is still true, then it will loop around and check it every time, but it will only check it at the end. While loops will check the condition as the first thing it does, and then check it every iteration. So let's move our code down into here, and let's just comment out our while loop just to see how this works. And if we run it again to make sure it's working fine, 10, 10, 90, 90, 50, and then finally 100, and it says well done. So you could be thinking, what are the differences between a while loop and a do while? In certain cases, you want the while loop to make sure that this condition is true before even continuing. In this specific case, we always want the user to answer the question. It doesn't matter if it executes once, because actually that's the behavior that we want. We've asked the user a question right here, so we want to always be looping at least one time. The while loop user case doesn't quite apply here, because we don't necessarily have to check if they've answered correctly if they haven't even inputted a value yet. We always want to be able to give them the option to do it once, and then we check their answer at the end. They could get it on the first answer, 10, 10, 100, and it'll still be fine. The same is true with a while loop, but it'll be easier and it makes more sense to read your code. When you have a while loop, you can see that this bit of code depends on a condition, whereas in a do while, the first iteration does not depend on anything, but the second and third and so forth depend on the condition. So depending on your user case and what situation you want to use it, you should either pick a while loop, which will only occur through a condition, or pick a do while that will occur once or multiple times after the first condition has passed. So when you have if statements that are pretty basic, you can actually make them quite easy to read through the conditional operator, also known as the ternary operator. So let's see how this works. Let's say we have an int age and we set it to a minus value. And we know that this value can never be someone's age because it's negative. But let's say that we have a situation where you ask the user for their age and they've accidentally typed in -10, and we know that that value is not actually true. So we could write something like this: age is greater than or equal to 0. Then we can print out valid. And then in the else, we can take this console write line and we can print out invalid. So that means if we run our code now, you can see that it says invalid. And if we change it to +10, now it says valid. So this seems a little bit long. We are just checking one condition, printing a value and printing another value if that condition returns back false. So our conditional operator works like this. We have a condition, followed by a question mark, then the value if it returns true, then the value if it returns false. Let's see how you can rewrite this if statement into one simple line. So let's take this in steps. These two values are both strings that we've typed in. So let's make a string and we can call it result. And let's make it equal to our ternary operator. So the first step is to get the condition. And the condition in this case, if the age is greater than or equal to 0. We can follow that by a question mark. And then if this returns back true, we want the string to say valid. and we can have a colon, and if it returns back false, then we want the string to say invalid, and we can add a semicolon. And then straight after it, we can just have a console write line that just says result. As you can see, now that we get it twice, we can verify one comes from the if statement and one comes from the ternary operator, and now if we make this a positive 10, then you can see it both says valid. So if we comment out the if statement and just see this running on its own just to double check, there we go. And because this is just returning back a string, we can actually just take all of this code in the conditional operator and paste it straight into the console write line. So you run the line of code now, we get exactly the same thing. If this hurts the readability of your code, then it's best to just store it and then use it after, if you can read this code and it's better for you in the long run. Later on, you might want to dismiss this variable and do it straight inside the brackets just to save a variable and then print it onto the screen straight away. It'll be better for memory if you just print it out straight away, but if you're not familiar with this notation yet and you want to get used to it, then that's fine as well. So a quick recap, we had an if statement with a condition, and if this returned back true, we printed valid, and if it returned back false, we'd print invalid. And this is pretty simple. The only difference between these two paths is this string literal that we've typed into here. So we can pull the string values out and place them in our conditional operator. We can say string result is equal to, if the age is greater than or equal to 0, then we store valid inside result. And if it's not greater than or equal to 0, then we can store invalid straight in our string. After we've stored this value, we can print result straight to the screen, which will either give us valid or invalid. When you're dividing two numbers, you might get an ugly output just like this. The user sometimes doesn't want to see such long decimal places, and maybe you just want to prevent it to 81.03. In order to do this, we need to use a format pattern so the language understands what we're trying to achieve. So if we make another console write line, what we can do is use string.format, and inside the brackets we can give it a format and then the object that we want to format. So in this case, the object in the second parameter is our value. So let's open some speech marks, go to the next parameter using the comma, and just type in our value. And then inside the speech marks, we want to type in the pattern. If you type in curly braces 0, then 0 represents the first value in this list. We can do a space followed by curly braces 1, and then add another comma, and we can add 1000. And what this means is value will get placed where 0 is, and 1000 will get placed where 1 is. So let's run this. And you see the exact same things happened, plus a space, and now we have the 1000, which follows this pattern exactly. If this is confusing, don't worry too much about it, I have the next section all about string functions. So let's get rid of the 1, followed by the 1000, and run it again, and we should see the output being exactly the same. There we go. So now let's see how we can make this better in terms of decimal places. So just after the 0, and the 0 represents the first value, we can add a colon. And this colon will tell us what format we want the value to be displayed as. We can type in 0.00, and what this means is all the numbers before the decimal place will get displayed, and only two numbers after the decimal place will get displayed. So let's try run this now, and you can see that the code output is a lot cleaner. One thing to note though, by default this will round it up. 0.37 becomes 0.4. Not to worry though, because this is what the user will see on the screen and it won't affect the actual value of the variable. If we print out value straight after, you'll see that the difference hasn't been changed. It's still 0.3 in the original variable. So that's one method of doing it. What we can do now is just use Ctrl D and copy it down, and we can use different formats to show you what it looks like. If we remove the 0.00 and then one of the zeros and leave it like this, and it gains one decimal place each time, you'll see what the output looks like. We just have the 81, which essentially makes it into an integer because it's a whole number. And then we have 81.0, and the reason why it's 0.0 is because 0.3 will round down as it's under 0.5. The 0.03 is going to round down as it's under 0.5, so it'll round down to 0. And then finally we have the 81.04, and just like before, this will round down to 0.4. And just like before, this will round down to 0.4. This will round down to 0.04. Let's say you wanted to get rid of trailing zeros because you don't want them, then you can actually change this 0 to a hashtag. once you run the hashtag, then it will trim off any trailing zeros. So what this means is it will try and put it in this format, but if this format happens to be a 0, then it will just keep it like this. And if you just have 81 dot, then it will also get rid of the dot for you, so then you're just left with 81. It's really up to you as the programmer what you want to display depending on what context. I'm just giving you the options that you have available. So let's say we want to work with money now, and we have a 10D divided by a 3D, and what that value would be is somewhere between 3.333, and this will be reoccurring because it's exactly 1/3. The reason why I've got D's in here is because these are registering as doubles. If you type the value in normally, it'll get registered as an int32. And the problem with int32 is when you do this division, it will process the division as an integer and then store it as a double. The issue with that is, in this case and in this case, both values will get truncated. Let me demonstrate. If I remove the D from both sides, and down in here, it will see what the difference is. And let's print out money. And then see what's happened. In the first case, this isn't actually an issue because we have a decimal place here, which means this will be a double. So an integer divided by double will give us a double. But we just place the D here just so we don't forget, and it makes the compiler's job a lot easier because it doesn't have to convert it from an integer to a double. In this case, we have an int that's divided by an int. So we'll get 3.3 reoccurring, but because it's processing as an integer, then we just get 3 being displayed. And this is not the intended result. So let's just replace these back to D's and we'll see what we get now, which is the 3.3. Perfect. So let's say that we want to display this as actual currency because you never see it displayed like this. It's always to 2 decimal places, just as follows. So we can follow the same approach as above. We can do string.format, 0:0.00, end the curly brace, and then common money because that's the variable in reference. Now if we run that, let's see what happens. 3.33. That's perfect. And now what we can do in here, because this is the pattern, we can actually type in anything before or after this and it won't affect the pattern. Just like so, we've added some extra spaces in here. So if we get rid of these spaces, we can actually just place a £sign in front of it, and then let's see what happens when we run it. Perfect, so now we actually have some money. And we can say in here, £10 divided by £3 equals this. And now our output looks a little bit better because we have some formatting. Now the issue is, when we start getting into negatives, let's see what happens. So we can say negative £10 divided by £3 equals something. And when we run, we'll see that the format is actually incorrect now. You never see the negative symbol after the pound symbol. It's always this way around. In this case, what we're doing is we're telling the compiler, hey, we only want to see 2 decimal places, but always keep it in this format. The £sign followed by the value. And the value of money is -3, so it'll place -3 inside here, and then add the £sign before it, but we don't exactly want that. So we can add something called a culture info, but we can also give it some other formatting some other way. So let's explore some other options. If you use money to string, then what we're actually doing here is using the double variable and converting it to a string, and we get passed back a string representative of this value. And that's fine, and when we run the code, you'll see no difference between these two. At this point, they're both being converted to strings, but what we can do in this case is when we open these brackets, it tells us there's 1 of 4. What does this mean exactly? So in our toString function, we have 4 ways that we can call this function. The first way, you give nothing in the brackets. And if we press the down arrow, the second way is to give it a format provider. The third way is just a string format, and the fourth way is both a format and a provider. So we'll use all of these in a second, but let's explore the easiest one. If you add a string in there, which gives us the third overload, a string format, and we can just type in a capital C, let's just see what happens. Perfect, so now we have the best format displayed to us. And the reason why this works is the C# program will recognize that the format of C is telling us that we want to display currency. So then it's going to your local machine and figuring out where you are based on your date and time, just down here. When you have a just date and time, it'll figure it out based on this. We have UTC time and we have the date and time listed up here. Based on that information, it can figure out that we are indeed in the UK and we want to display a £sign, And because the program knows that it's negative 3.33, it'll put the pound sign in the right location. So now that we've explored C, let's have a look at the other ones that are available. So if we use Ctrl D and copy this down 3 times, we can use C0, C1, and C2. And now if we run this again, you'll see what the output gets you. C will get you currency in its most native form, which is what we're used to using in the UK. C0 will only return you back with the whole number, C1 will give you 1 decimal place, and C2 mimics C on its own as they're displaying the same values. Now this is where it gets interesting. If you want to display different currencies, then you're going to have to use this thing called a culture info, which will be able to retrieve back different currency formats based on a certain country code that you give the function. So let's have a look and see how that works. If we scroll to the top, we can add a new library called system.globalization. Inside globalization, we have a culture info. So let's see how we can tailor these to make it look a lot better if you're worried about different currencies. So if we use CW tab, and we do the same thing, money.toString, we add our C, and this is where our format provider fits in. So we can start typing culture info, and it should come up like this, press enter, and inside this is a class, that's why it went green. If we press dot, then we get the current culture. The current culture will decide based on the machine that the program is running on. If this program is running on a cloud computer, and the cloud computer is stored in Europe, then it might display euros, and if it's stored in America, then it'll display dollars. So you want to avoid using current culture if you're going to scale your program worldwide. In the case of this example, I'm going to leave it, because as you can see, when I run it, it will display the same thing as the other ones, because this one will also recognize that my current culture is UK, and I'm also telling it to use the current culture. So in both of these cases, it's figured out that my current culture is indeed the UK, and it started using the pound sign. But let's say we want to give it a different culture. Then what we can do, if we duplicate this line using Ctrl D, and remove this section just after the dot, we can actually say create specific culture. And inside the parentheses, we can actually add a string, and it says here, a predefined culture name or the name of an existing culture info object. The name is not case sensitive. So in the case of the UK, you have English GB. And now we need another bracket at the end. And then if we use Ctrl D to copy this down, we can change GB to US. Let's run this again and see what happens. These two don't actually output anything different because we're just doing the normal culture, and then we're telling it to find the GB culture, which is exactly the same thing for me. So we get these two values exactly the same. And apparently it's picking up that in the US you have brackets around your negative values, which I can't personally validate, but this is how it's showing up. So let's try some other cultures and see what happens. So you can try ENAU for Australian. Then you can see that they actually use a negative followed by the pound sign and then the value. So even though they're both in dollars, one's US dollars and one Australian dollars, and apparently the US uses brackets for their negative values, but Australians use the negative value like we do. So let's just have a quick recap. So we can display the value just like this, but we'll have a problem with multiple decimal places. We can use these format options to give us 0 decimal places, 1 or 2 decimal places, and then when we use this format, the problem with it was when you display negative numbers, you get a nasty format where the negative value actually comes after the pound sign, which is not correct, and you don't want to output that to your users. Instead, you should use the C format. It'll tell the compiler that you want to process this as a currency. Currency processing is better because the software will understand that the value you're trying to represent depends on a certain strict format, just as follows. You don't want the negative to be here instead of before it because that doesn't look very nice to the end user. Alternatively, you could use this culture info if you're going to scale your program. Scaling your program means that it's going to live on servers, and this culture info, especially the current culture, depends on where the program is being run on because it depends on the system time. Different servers will have different date times set because they'll be in different countries. So you want to be careful, and if you want to display in a certain currency, you can create a culture specification and pass the country code inside the brackets, and then you'll get the correct output, and it doesn't matter where your program lives. If you always want to generate in pound symbols, then you always use create specific culture and always specify ENGB. Upon doing so, you'll always get the pound sign and it doesn't matter where your program lives. So throughout this course, you've seen this notation a lot. Print out a value using console write to give the user an opportunity to write on the same line, reading their value as a string and store it in a variable, and then use that variable to convert it to an integer 32, and we're passing the string input inside here, and then we convert it to an integer. If we run the code, you can see that this actually works perfectly, assuming you actually enter a real number, like 10. We press enter and it works and it outputs back to the screen using this console write line. And then if you press this restart button, we can start the program again, and let's say we accidentally type a character like L, and we press enter and we get a format exception now. This is problematic because our program will now close. If we press continue, it doesn't even hit this line or this. As soon as it hits the exception in here, our program just closes. If we use debug, start without debugging, and now we're actually running the program outside of Visual Studio, so we won't get that pop-up when the error happens. Let's see what happens if we type this in now. We can say 10p and press enter, and now we get that the program has stopped working. You've probably seen this pop up a lot throughout Windows and different versions of Windows, because when a program has a fatal error or an exception, you see this pop up appear, and the only thing you can do is either debug or close it. Normally the debug option isn't available, but because this is a C# program and it's made through Visual Studio, and the Visual Studio has been installed on the system, then it gives us the option. But really, all we can do here is just terminate the program. It doesn't matter what happened because we can't recover this. If we press close, then it's literally just going to close down. It's going to tell us the exception and then press any key to continue. And as soon as you press any key, then the program just closes. So this is very fatal for our code, since if we had some precious data stored in here or anywhere else in the program, it is now lost before we can do anything. This is problematic and we want to avoid this. The best way to do this is to use something called try parse. Right here, the program is assuming that your string input is a perfect input, and then you're immediately converting it to an integer. Now, like I said, what if this had 10h in it? The program is going to cause an exception, and then the program's going to close. So let's see what we can do with this try parse function. So the notation is int.tryparse. The first parameter is a string s. String s is a string containing a number to convert. So what this tryparse function will do, as it says here, converts the string representation of a number to its 32-bit signed integer equivalent. A return value indicates whether the conversion succeeded. Okay, perfect. So we'll get into that in a second. So our string s is a string containing our number to convert. And in this case, we want to be using the num input. So we copy and paste that down, and then we add a comma because we have more than one parameter. Now we have an out int result. When this method returns, result, which is our integer, contains the 32-bit signed integer equivalent of the number contained in s, and s in this case is our first parameter, which is num input. If the conversion succeeded, then we get the value inside our result, or 0 if the conversion failed. The conversion fails if the parameter s is null or string.empty, is not of the correct format, or it represents a number that's less or more than the maximum value that the integer can store. This parameter is passed uninitialized, any value it originally supplies in result will be overwritten. Let's dive in to see what this means. Because it's an out int result, what this means is we can actually process a variable inside here, like int num. So we can say out num. And what this will do is when this line executes, it will try and convert num input and place the value inside num. So we don't need to run this convert anymore, we can just specify that num is equal to 0. So we've read in the string that contains our 10h, and we have our num that contains 0. Let's just remove this console write line. So now we have our variable set up, let's see what happens. If we do a console write line and just print num after this, let's see what happens to the code. So if we type in 10h and press enter, the value of num is 0, but what do you notice now? The program hasn't closed because it's tried to parse it instead of just parsing it automatically and then cause an exception. So the reason why try parse is called try parse is first it tries, and then if it succeeds, this will contain the value, and if it doesn't succeed, this will contain 0. To know if the number has actually been converted, we actually have to use the bool return value. So what this means is, because it returns us back a bool, we can store it inside a bool. and we can give it the name of success. Bool success equals int.tryParse. We try and parse the num input and we place the value inside num. The reason why having this bool success is very essential, let's say for example the user actually enters 0. So technically as of this point, num0 is actually correct because we've got 0 and we initialize it to 0. But of course after the tryParse runs, this is still going to be 0. Now we don't know if the value 0 is because this has succeeded or the value is 0 because we initialized it to 0. Let me demonstrate. If I type in a 0 here, is this 0 being converted because this was successful, or is it presenting me 0 because this has been initialized to 0? And the only way we can know is because our tryParse will return us back with true if S was converted successfully, otherwise false. We can actually write an if statement in here. If success. Open the curly braces and we can start to type something in here. So we can take our console write line and place it up here using Alt and up arrow key, and then in the else we can say failed to convert. So now we have a mini setup here. If it's been successful, we print out the number. If it hasn't been successful, then it'll go into this path and it'll print failed to convert. Let's have a look and see how this works now. If I press 0 and I see 0, that means it's followed down the success path, and this 0 actually means it's converted my input instead of just the value that it's been initialized by. If we run the code again and type in 10h, then we actually see it says failed to convert. And why that happened is we have 10h up here, and then this will return back false when it tries to convert num input, and then after it hits this line, since success will be false, it will dodge this path, go into this path, and output failed to convert. What you can do if you really wanted to is you could wrap this around in a while loop, so let's see what we can do. So we can specify a bool success and make that equal to true, and then we can add a while loop with success in there, and then open the curly braces and put all of this code inside here. Now we're going to have some errors because we got success twice, but what we can do, which will be a lot easier, is we can place this straight inside our bracket. And the reason why is because this returns us back a boolean, so we don't need to store it and then use it. Another thing we can do is instead of having int num and then num right here, you can actually make this a declaration as well. So if we just remove this value, we can write out int num. And this will do exactly the same thing, it just uses less variables. While our success is true, we come into here and run this code. If we fail to convert, then we still want it to be true so we can loop around. If we've converted it and the value is successful, then we can actually make our success at this point false, because that will stop the while loop from going around. Let's run the code. We can type in 10h, 10e, 10a, etc, and as soon as we type in a real number, then it will print it out and the while loop will cancel, and now right here we're sat on the console read line. Now if I press enter, the program will close. So let's have a recap. We use int.tryParse so we can try and parse a value before the program assumes that the value is in the correct format. We give it a string variable and it returns us back with a fresh new integer called num, or whatever you want to call it inside here. We can place this straight inside the condition of an if statement because this function returns us back with a true or false value, otherwise known as a bool. If this has been successful, we stop the while loop and print the value out to the screen, and if it hasn't been successful, then we print failed to convert, and because our success is still true, it will loop back around to the start of the while loop and ask the user to input another value to try and convert. This while loop will only exit if it's indeed been successful, and the only way it can exit is by having the success being equal to false, and the only way that can happen is by having a successful conversion. The use of tryParse in every program is very essential, because if you have a fatal exception, then your program will close and you will lose all the data. The problem with that is you might lose anything that you haven't processed yet at that given point in your program. So you want to try and use tryParse because you'll avoid any potential exceptions, and you can let the user know if the conversion has been successful or not, and write yourself the same while loop just like this So you can tell the user, hey, you input it incorrectly, but this is how to do it right, and make sure that your program doesn't execute incorrectly. And make sure your program doesn't just close unexpectedly and then an error will be caused. In this exercise, I want you to print out some sort of times table. And what I mean by this is you want to ask the user to input a number for the table and then write a for loop to print out the x times table. X is dependent on the value that they entered. If they enter 10 in here, then this will be the 10 times table. Let's get started. So we can have our normal console.write, enter a number, and then use our int number equals to convert to int32, and we can say console.readline because we want to read whatever the user types in. Then we can have a for int I equals 0, I is less than 10. We're only going to print up to the 10 times table. So 1 times something, 2 times something, all the way up to 10 times the value that they entered. Immediately we acknowledge an error here. When you do your 10 times table, for example, you do 1 times 10, 2 times 10, and so on and so forth. The issue here is we're going from 0 to 10. But because it's less than 10, we're actually going from 0 to 9. So let's change this to 1 and then less than or equal to 10. In both cases, we were actually looping the same amount of times. The issue is this was starting on 1 and the other one was starting on 0, and the first one was finishing on 9 and this one's finishing on 10. And we want them to go from 1 till 10 instead of from 0 till 9. Even though that's the same amount of iterations, it gives us different values. So in here, we can just have a console write line. And this is how it's going to work. We're going to have our first number times by our second number, and that's going to be equal to something. So our first number is our value of I, because that'll say 1 times something, 2 times something, and so forth. Our second number is whatever the user has typed into the calculation, which will be number. And our third number is going to be the actual result of the calculation, which are these two times together. So we can have I star number, and that should be it. Let's run it and give it a shot. We can do our 10 times table, and if we press enter, you can see that it's fully working. This will be our I variable going down the side. The second number is what the user's typed in, and the third number is this multiplied by this gives you the output. Let's run it again with a bigger number, and it seems to handle okay. And because this is an integer, you'll expect to work okay up until around 2.1 billion, which is a big number for some times tables anyway. So just a quick recap, we looped through from 1 till 10 instead of from 0 till 9 because we made sure that when we do our multiplications, we don't want to start the value at 0 times something, we want to start the first one at 1 times something, and we don't want to end at 9, we want to end at 10, so using 1 and less than or equal to 10 will get us the values that go from 1 till 10, and that'll make our output look a lot more concise. We're using conditional formatting here, adding the 0 and curly braces, and then the 1, and then the 2. And in order to insert the values in, it's a comma delimited list after the speech marks. The first one goes in the right order, 0 is I, 1 is number, 2 is I times the number. Running that code, we'll get this output. There you go. So in this exercise, I want you to have a look and see if you can make the FizzBuzz game. FizzBuzz game is one of the most popular interview questions you'll come across. And the way to do this is to create a for loop from 1 to something. In this case, I'm just going to use 15. And inside the for loop, you want to decide if the number is divisible by 3 and 5, then you want to print FizzBuzz. If it's divisible by 3, then it's fizz. 5, it's buzz. And if it doesn't fall into any of them categories, then you want to simply just print the number out to the screen. Let's get started. So we can have a for, and because we know how many we want to do, we want to do int I less than 15, I plus plus. And then inside here, we need to use the modulus operator, which is the percentage sign. So if you remember from the tutorial, in order to figure out if a number is odd or even, you could do the number modulus 2, and if that value is 1, then it must mean it's odd, and if that value is 0, it must mean it's even. But what we can also differentiate from here is if 10 modulus 2 equals 0, then that means that 10 is divisible by 2. But also it is even. And if it's even, that means it's divisible by 2. If it's not divisible by 2, that means it's not even, and therefore it's odd. So in this case, if we're trying to divide 3 and 5, we can have the same calculation, but we can work it out differently. So 10 modulus 3 actually gives us the value of 1, because it's 3 remainder 1. So if this value is anything other than 0, then we know that these two were not divisible by each other. 9 percentage 3 equals 0, which means it's divisible by it. So in our if statement, we can say if I, which is the number that we're currently up to, percentage 3 equals to 0, and because we want to check for 5 as well, we want to say and I percentage 5 equals to 0, and that means they're both divisible by each other. So we can do a console write line and we can say fizz buzz. And then in our else if, we're going to check if it's 3, and we can repurpose this exact condition because this just checks if it's divisible by 3, and then we can print fizz, and then if we copy this exact structure down and change this to a 5 to check if it's divisible by 5, then we can print out buzz, and in the worst case scenario where none of them get applied, then we can simply print I to the screen. And actually there's no point in starting at 0 because normally these start at 1, so we'll just do 1 and we can make it 15 by making it less than or equal to. So instead of before it was actually going from 0 to 14, now it's going from 1 to 15. And they will tell you this in the interview. They might say, counting from 1 to 100, print out all of the fizz buzzes. So let's run the code and see what's going on. 1, 2, fizz. Fizz is actually 3, so 3 is divisible by 3. Then you have 4, and then 5 is divisible by 5. You get buzz, and 6 goes into 3, so you get fizz. 9 you get fizz because it's divisible by 3. Then 10 divided by 5 gives you buzz. 11, 12 goes into 3, so you've got fizz. And finally, when you hit 15, it goes into 3 and goes into 5, so we get fizz buzz. And the way to increase this to 100 is by simply changing this to 100 if you need to. And you can scroll through the entire input and you can see all the history. If you wanted to make this slightly efficient, what you could actually do is store the Boolean values for these calculations before. You can store the values for these calculations before. So we can say bool 3div equals false and bool 5div equals false. And what we can do at the start of each of the for loop is we can say 3div equals this value and 5div also equals this value. And then every time we find a calculation for 3 or a calculation for 5, we can replace it with either 3div or 5div. So let's change this one here and this one here and our 5 here and here. And because these are values now, we want to actually store them as true or falses, so we don't need to check if they're equal to 0, so we can just remove them. So we can say if 3div and 5div are both true, and they'll only be true if these two are both 0. Now if we run the code and just make it 15 again, just so we have a shorter output, you can see that our code is exactly the same. The reason why this is more efficient is we're only doing this calculation twice, whereas before we were doing it twice for 3 and twice for 5. Now we're doing it once, storing it, and then making use of it. This is a lot more memory efficient than having to calculate it every single time. It computes a lot faster, and it's better for readability. If the rules of the game happen to change and this was divisible by 4 or 6, then you could just change it very easily, whereas in the previous example, you would have to change it in every single case. In C#, when you're constructing strings that have backslashes, you're going to need to use double backslash. And the reason for this is the first backslash is an indication that it's actually going to be an escape character. You're going to put an escape character in and then put the character that you want to display. And the reason for that is they've chose backslash as the designated character. So you can use backslash and then a backslash to show one backslash only. And what this means is it will use the first backslash as a reference so it knows that it's going to process the next character as an escape character. And what these escape characters are, you can have things like T for tab, N for new line, and you can even use speech marks. Because if you're outputting some dialogue and you wanted to say something like this, he said, and then you added your own quote in there, if you want to put something in quotes, then you can't, because the speech marks dictates that this is the end of the string literal. That's why it's cutting it off like this, and then now it's not recognizing that something is just wrote here, and what it's actually doing is you've got two strings specified. One that says he said space, and one that's just empty, and then you just have this something that's just in the middle. Of course, we actually want to insert the speech marks within another pair of speech marks. This is where the backslash comes in, so you can insert a backslash before here, and this is now acceptable. And the same thing with the normal backslash. Because the backslash character is also going to be the escape character, then you need a double backslash, so then that equals to a single backslash when you print it out. Let's show an example. So we have C:// which will return us back a single slash, but visually right now it's a double slash, but when it gets processed or outputted to the screen, you'll see that it's a single slash. So this common example is when you're constructing a path together and you want to use backslashes to denote the different directories. So let's output this to the screen and see what happens. And as you can see, we have a single backslash. Because of the escape character, we don't see both of them. And if we print the speech out to the screen just to show you that as well, then we can see that there's only the speech marks around the something and we don't have the backslash. You can tell when an escape character is being used because it goes a slight hint of yellow instead of the normal color for a string. So now that we've worked out that this is how this works, let's see a way that we can undo this to make it easier for us. So you've used the $sign for string interpolation and you've used the plus just to concatenate two variables together. And just as a quick example, it looked something like this. Your name is, and then the name variable. And using the plus, you would say your name is, followed by a space, and the quotation marks and do plus name. That's fine, and now we have another one. So similar to how we placed a $sign before the speech marks, we have a verbatim identifier. And what this means, because it says verbatim, it just means whatever you see is whatever happens. So let's try and define this path a slightly different way, but still containing the exact same information that you see when you print it out to the screen. So let's have a look. We can reassign the path value, and just before the speech marks, we can put it @ symbol. And this @ symbol means it will actually negate all of the escape characters. It will process a single backslash as a single backslash. Let's take this line of code and place it inside here. Now what you see is that tint of yellow is no longer there. So if we print this path to the screen, let's see what happens. We actually get the double backslash because it's ignoring all the escape characters, which means if we take them all out, this actually looks exactly how we want, and you don't have to worry about the escape characters. There you go. These two are identical even though one is being displayed using escape characters and one's using the verbatim identifier. Please note that if you're going to use the \n for example, and I'll just demonstrate at the end of this, new line test, and if we run that code again, you'll see that it's printed the path on one line, the \n has made it go on to the next line, and now it's printing new line test on a dedicated line. And that's fine. The problem is, if you use a \n or a \t or any of these escape characters during the @ symbol, then it's going to process it as literal characters, which means you can't mix a \n with an @ symbol, as this is just taking the text verbatim. So if we try to run the code now, you'll see the \n will actually appear in the code. If you wanted to do this, then maybe you could remove the \n and add a plus at the end, and then make another string that just has a \n, and then this string will not be processed as a verbatim string because we don't have the @ symbol right before it. So then we can have the exact same thing here just to show you this. So now these two are identical again, just as shown here and as shown here. The difference being that we can't specify a \n in the same string, we actually have to concatenate them together because of the verbatim identifier. So let's have a look at speech marks. So if you have a string name and we can make this equal to hello and then someone, and we said before that we have to use the \/ so we can activate the escape characters, and that will work. And if we just print that to the screen to make sure, Then we get hello someone in the speech marks. If we add the verbatim identifier at the start, then we see we've got an error. It's trying to process it differently. This is a little quirk with the verbatim identifier. If you want to insert a speech marks, you actually want a double speech mark on either side. The double speech marks will get processed as a single speech mark. Because it's within a speech mark, the verbatim identifier needs to know that you're specifying a speech mark, and this acts as the same reason why you have a backslash here. It's slightly quirky doing it this way, but it still works as per you expect. And when you're specifying something like name, and we can say hello someone, so let's print name to the screen and make sure it works. In this case, we don't actually need to specify any sort of escape character because the quotation mark is a separate character to the speech mark and it doesn't interrupt anything by placing a quotation mark inside. The string just represents that as its own character. Let's run that and make sure it works. There you go. So just as a quick recap, escape characters are very essential because we can use things like \t to give us a tab character in our console output. This can be very helpful because you can almost mimic the use of columns inside our console output. You'll notice that \n is used quite a lot in the console output, so you can separate lines without having to use multiple console write lines. If you have a single backslash, you can't have it on its own if the string is not a verbatim string. You have to pair it with another character, otherwise you will get a syntax error. If you want to use the verbatim string, then you can put an @ symbol before the string definition and then it will ignore all of the escape characters. For example, using \n within these speech marks will mean that the \n will literally be printed to the screen and you won't get the new line functionality that \n provides. When you want to print speech marks to the screen using the verbatim identifier, you have to use a double speech marks in order for it to show up. And as you can see, it slightly goes yellow, and that's the similar notation as using escape character when you don't have a verbatim string. If you're using other characters that are similar to a speech mark, like a quotation mark, because this doesn't interrupt the syntax of the language, then this is fine because a character can just be inside a string. And to the compiler, this is just a character even though they are very similar. The quotation mark doesn't affect the speech mark. The most common approach for outputting values to the console is by having this format. You type something in as a static string and then you add a variable to it. But when you're doing long sentences, this format can get messy quite quickly. So this will just output both of these on separate lines, the name followed by the name variable and the age followed by the age variable. I just have a console write line to split up these two sections just so you can see it visually in the console. So if we run this code, you can see that both the outputs are exactly the same. And the reason why is we can use this \n. What this \n is doing is inserting a new line character just where my cursor is here, which is forcing the age to jump onto the next line. The reason why this is a slightly different shade to the age text is because it's an escape character. \n means new line. We'll explain this in a further video in this section, so don't worry about that. Just know that it means that it produces a new line. So as you can see, since we're adding the name, followed by the name, and then the age, followed by the age, then it's getting a bit long and a little bit tedious. It's not too bad in this case because we're not really printing out a sentence, we're just going straight to another line. But let's see what this is going to look like if we start dealing with multiple bits of data. Your name is, followed by the name, and then we can add a comma, and your age is, and then add the age. And as you can see, while we're structuring a sentence, then it gets a little bit long. We have to remember to put in the spaces, otherwise our code is going to look funky when we print it out to the screen. And the reason for that is there's no spaces between the name and the age variables. So let's put them back in and make sure the output looks alright. Now that the output looks like this, let's explore composite formatting, and what this means is we can get rid of all of these plus symbols and replace it with curly braces. So let's actually output this string again, but just output it completely static. Your name is Abba, and your age is 23. And now if we run this, you'll see that both outputs are identical. This is because I know the values for the string variables up here, and I can input it straight into here. So now that we know what our sentence is going to be, we don't need to add any pluses. What we do need to do is remove our variables. So in the case of this sentence, our name variable is here and our age variable is here. So we can replace this with this curly brace notation. We can have curly braces and then we want to start this value at 0. Throughout the string, you want to have these values starting from 0 and going up incrementally from left to right. So our next variable would be our 23, and we can store it like this. Now that it's got your name 0 and your age 1, let's see what happens when you output it. Then we just get this, and this is very confusing. That's because we're not done yet. So now that we've got our string typed in, we can actually place a comma in here, and now it lets us put any object in. And any object could be a string, an int, a double, or any data type. So we want to insert the values inside here going from left to right. So our name is first, and then we do a comma and we type in age. And what this now says is the name will get replaced by the curly brace 0 and the age will get replaced by the curly brace 1. So now if we run the code, let's see what happens. And now you'll see that the output is exactly the same. And now look at the difference between these two lines. You'll see that these multiple amount of pluses are not confusing, and let's say you forget this one, then you're going to get a syntax error and it's a bit frustrating to keep on typing when you're trying to join things together. Now we can clearly see that this flows like a sentence, and this space here looks very unnatural, but this space here looks like it's part of the sentence, which makes our code a bit more complete. And the same goes if you want to print something like this, and let's convert this one. So if we copy this line down into here, and we just remove the spaces, then it can look something like this. Name followed by the name, and we don't actually need this space here because we're going to be going into a break line. We can replace our name with curly braces 0 and our age with curly braces 1. And then straight after we can type name and age, and if we output this, we'll see it's exactly the same. There we go. So just a quick recap. Printing strings and any other variables to the screen has been normally achieved by doing a string followed by a plus and then adding another variable to it. Adding more than one can be a little bit complicated and hard to track of all the spaces that you're going to put in, and you might accidentally miss one of them. Like this one here or this one here are very crucial to the output. If you miss this one, then it's going to say is followed by the name all together with no space. We then introduce composite formatting, which lets us use this notation of curly brace 0 and curly brace 1 to give us the ability to store some variables outside of the string and then insert them in dynamically. We took both of these examples and made them down here using composite formatting. So let's explore a new method of concatenation that makes this look a lot better. The reason why this is an issue is you have spaces in here, and sometimes you might forget these spaces and it could mess up your program. This string here looks very unnatural because you're forcing the space, but when you run it you'll see that it is actually what you expect. The spaces are complete and it makes perfect sense, but when you're writing it, it kind of looks a little bit stupid because you're forcing the space and then adding a plus and then the name and then another plus and then another static string, and these just get a little bit long to type. It's fine when you have a smaller sentence like this, but when the program starts to grow, then it could be a little bit problematic and you'll have a lot of syntax errors when you forget to type in all the pluses. Luckily, this can be fixed. Let's duplicate this line down and let's see what we can do. So we have this thing called string interpolation, and it uses a $sign as a reference. We can place the $sign before the quotation marks, and then what you can do is you can actually keep this as one big sentence. So let's remove all of the values and have it like this. So now of course this actually doesn't print our variables because we've just replaced it with text. So if we just run this, then it's completely messed up because now we're not using our variables. And this can be easily fixed. Because we've used our $sign now, we can actually wrap our variables in this curly brace, and now you can see it went white. If I double click on it, you can see that it's referencing the variable. Wrapping the variables in the curly brace means that they can actually be processed as variables even though they are still within the speech marks. Please do not remove the $sign because now this will be interpreted as string text, as you can see here. Putting a $sign at the start will make it into string interpolation, and then we get the ability to have our brackets. This can make string concatenation very easy to do because you don't have to worry about all the pluses and adding them together, and don't have to worry about the spaces as well. This looks more like a natural sentence, and what you can do for practice is you can actually just type out the sentence. Your name is Abba, your age is 23, and then from there you can actually just break down the variables and know that you'll need one here, so you can replace that with name, and then you'll know you'll need one here, so you can replace that one with age, and then you can place the $sign right at the end, and then there you go, you have your solution. This method means that it's a lot cleaner to read, easy to maintain and make changes in the future, and that's the whole point of programming. If your code base is very difficult to go around and understand what's going on and potentially make changes in the future, then you've already made a bad step and you don't want to get into these nasty habits. It's fine if you're just going to have something like this, where it's not really complicated at all. A string plus another string, that's quite simple and that's fine. You don't have to go the extra effort to put in the $sign and wrap it around in the curly braces, even though I personally still would, because in my personal opinion, this looks a lot better than having it like that. You can see that it's a lot neater, it takes up less code, and you can see visually that you're using a specific variable, and you don't have to worry too much about the spaces because this looks like a real sentence. Explore another method of string concatenation, which is the idea of taking strings or objects and adding them together to form a sentence of sorts. We can say your name is, followed by a space, and then add the name, followed by a space, add your age is, and then add the actual age variable. And we can also write the exact same line using string interpolation or composite formatting, just like this and like this. We can specify the $symbol and put our variable in the brackets, which is shown here and here. And for the composite formatting, we can take the contents where our variable would go and replace it with incremental numbers 0 and 1 wrapped around in a curly brace, and then specify in the correct order. 0 takes the value of name and 1 takes the value of age. If we run this code, you'll see that the outputs are identical. So let's explore this other method. We have a string, test for example, and then inside the string library we have this function called concat. And it can take in any amount of parameters that we want to give it. So we could say your name is, space, and the quotation marks, and then we can add a comma, and then we can say we want to add the name, and then another comma, and we want to add and your age is, and the speech marks, add a comma, add the age variable, and that's it. And we could just use CW tab and type in test, and let's run it and see what happens. And now as you can see, we get the exact same output. And because this just returned us back with a string, we can also just take this entire line and paste it straight into the console write line. You don't necessarily have to store it, but you can if you want to. And there you go, all methods produce the same output. Another way you can use this concat function is by giving it an array. We haven't covered arrays so far, so I'm just going to show you this for demonstration purposes. Don't worry about understanding it. So just a quick explanation. Arrays are just ways of storing multiple of the same data type. So if we have these three names inside our names, we can actually use the console to print them all out. So we can say string.concat, and then we can concat the names together, which will just add all of these three together. Now the problem is when you run it, you'll see they're stuck together. So what you could do is just add a space between them. And as you can see, this is getting a little bit tedious now. There's other methods that we can use to concat some arrays together, and I'll show you that in the next section, but for now, don't worry about it. This is concentrating on the string concat function, and we'll just demonstrate that again. So if we run the line of code, we can see that they're all the same. So now that you have 4 different methods of printing out exactly the same information, you might be asking yourself, what's the best method? I personally prefer to use the string interpolation, because with this one, you can easily miss the spaces and you could produce a bad output and it might be stuck together. It's fine when you can see the lines right in front of you and you can easily identify the spaces, but when you're adding about 10 variables together, then it could be a problem. The reason why I like string interpolation using the $signs and the variables in the curly braces is that you don't have to rely on missing out spaces because it actually forms a sentence and you just replace the values with your variable. Composite formatting, which is this one, is very efficient and very nice to look at, because it allows you to specify the sentence and then plug in the variables after. The only problem with this is if you were to change this value in the future or to change a sentence, you have to make sure that the numbers add up. Just like in the first example, if you only have a short sentence, then this isn't really an issue since you can see it all visually. And you also got to realize that these need to be in the right order, because if you put age first, then it's going to put age in this one and name in the second one, and that's going to be problematic because it now messes up the sentence. Using string interpolation, you don't actually have to worry about anything, because if you wanted to change this to say your age is, then you simply just do this. And that's very easy to do, because in this case you'd say your age is, and then you'd have to change a string, and then now that this is 0, we need to change this from being age and this one to be name. Whereas in the first example, you could just easily change the value in the curly braces instead of changing this reference and the end reference. Concat is not widely used just because you have all of these methods available where you can easily add stuff together, but there could be user cases later on down the line where users, just so it's a bit more obvious and it helps the readability of your code and maintain within a big project or just on your personal projects when you're looking back at your previous code. When you create and initialize a string variable, you might want to give it the value of an empty quotes, and this will just default the value to essentially nothing. You're giving it a value, but at the same time the value doesn't actually contain any sort of characters. If we print this out to the screen, then you won't really see anything. This video is going to focus on string.empty, and string.empty will actually just represent these quotation marks. String.empty will represent these speech marks. So what we can do is we can type in string using a dot, and then we can type in empty. Just like that, we've initialized our string name to a value of empty. Now, this isn't necessarily used when you're declaring and initializing it, because this is almost identical to just defining a string on its own. Main reason why this is used, let's say we actually ask the user to input their name. So we can say a console.write, enter your name, and then we can take this string variable, move it down, using Alt and then the arrow keys, and remove this, and let's initialize it to a console.readline to read in the value from the console. And now what we can do is, using our string interpolation method that we just learned, we can print to the user your name is, and then the name in the curly braces. Now let's just see what happens. So let's actually type our name in, Abba, and it says your name is Abba. But what if the user just types in nothing and just presses enter? Then it still says your name is blank. Now let's see what we can do here. We don't necessarily want to say your name is blank, we want to check what this value is. So we can say if the name is not equal to empty quotation marks, then we can output your name is. And then else we can say name is empty. And then if we run it now and press enter, it says name is empty. So we can use string.empty instead of these quotation marks. This looks a lot better when you're trying to compare it. Abba, your name is Abba, and then when we press enter, it says name is empty. This just helps to keep your code a lot tidier, just so you don't have to write the two quotes. If you accidentally put a space in there, now your if statement is incorrect. If you always use string.empty, then it just helps you to make sure that your code is going to be maintainable and readable in the future. Reading string.empty gives you a better representation of what's going on instead of two open quotes. If there is a situation where you want to check if one string equals another string, then you can do the following. If message equals compare, then we can print out same, and then else we can print out different. And as we can see here, they both have a capital H and they both say hello, so they should be identical. Let's run the code and find out. So they say same, which is exactly what we'd expect. So we have another method of being able to do this. So even though we can apply equals to two strings, it's normally better practice to use dot equals and then place the other string inside the brackets. So you're saying if message equals compare. Now if you run the code, you'll see that it's the same output. In certain circumstances where you want to ask what the user has entered, enter your name, and then we can use a string name equals console.readline. We can say if the name does not equal to empty strings, then from there what we can do is type in your name is plus name, and then we get some output. Abba, your name is Abba. But since we're checking if it's not equal to that, that means they've entered something in. Let's see if there's another way that we can actually write this. So if we just duplicate it and comment it out so we've got it for reference. So what we want to do is we're checking if name is not equal to empty quotes. So we can say name.equals empty quotes. But what this is telling us, if the name equals empty quotes, then we should do this. So then what we can do when we learn about the if statements is we can use the not operator, and we can say if the name not equals to empty quotes, then we proceed with this line. Else we can just say invalid name input. And let's run that and see what happens. If we type in ABBA, then it passes fine. And if we type in nothing, then we get an invalid name input. The reason why equals equals and the dot equals function are different is because lower level using equals equals will actually compare the reference in the memory. And the reference in the memory is what's used up when you actually create these variables. So what this is doing is it's comparing the value that's actually stored in memory to the other one that's stored in memory. Now the problem is when it comes to something like arrays, where you actually have the same value, but they're slightly different. Let me demonstrate. So I'm just going to use this code because we haven't covered arrays yet, so I'm just showing you an example. If we have a chart array that literally says hello, and then we can use this line of code to join them together, but this is actually an object instead of a string. But if you see what we can do in the if statement, we can say if the message, which is equal to hello, we can use message.equals and we got the new compare. And this is actually an object. So now we're comparing a string with an object. And generically speaking, an object can hold any sort of value because all of these variables that are strings, ints, double, etc., they're all derived from something called an object, which is just a very generic way of storing information. So since these two data types are a little bit different, they still evaluate to the same thing. What the equals function is doing is actually checking the literal values of the variables instead of checking the values that are held inside the memory address location. And the difference here is, even though we have a character array that is giving us the values hello, and our string is also giving us the value of hello, if we run this line of code that uses .equals, then you'll actually see that the second same actually represents the bottom if statement. So what that's doing is it's actually giving us back the comparison saying that it's true. And it is indeed true because hello is literally equal to hello. But if you were to use the double equals, then what you'll realize when you run the code is now it will say it's different. Because what it's doing now is it's taking a string object and comparing it to an object. And they are not different because of their memory. And that's what the equals equals is comparing. It's not only comparing the value, it's comparing the memory address location. And that's going to be vastly confusing because you don't want to hit these situations. So it's always best to use the .equals function because the equals function is concerned about the values rather than where they are in your memory. I hope that made sense and it wasn't just confusing. But basically when you use equals equals, it checks the values that are actually wrote in your computer's memory instead of the value itself. It will do both. It will check the memory and check the value. Whereas when you use .equals, it is only concerned about the values. And that's all that matters when we're doing an if statement like this. We're checking if they're both the same. So it shouldn't really matter how and where they are stored. The only thing that matters is the values contained within the variable. We're only caring about the values and not where they're stored. So when we have a string variable defined in C#, we have it like this. And when we print it out to the console, we get the entire string being displayed. But what if you want to return the first element back and not the rest? Then what are your options? So in the later video in the course, we covered the substring function, and technically you could go from the first character till the second character and you will just get C back. So that's index 0 till index 1 and you'll get the C back. Now the problem with that is that's an extra function call for something that should be quite simple. And it is. A message is a string, and strings tend to be an array of characters, which is similar to this. We haven't learned about arrays so far and we'll cover that in the next section, but what an array essentially is it lets you store multiple of that data type. So we could have a chart array that holds exactly the same value, and each position will hold each one of these characters. And the reason why I mention this is because with strings you can use the square bracket notation. So if you add some square brackets at the end, it says here it returns back a char, and it takes in an index. Gets the char object at the specified position in the current string object. So if we use message 0, you can see that returns us back with a char. Char right here gets the char object. So we can call this on a string and it can return us back with a character. Because like I said with the array of characters, that's essentially what a string is. Each one of these is just its own independent character, and a string lets you pair them all together. So if we print this out, then we should get C, because it's 0 based. So if we copy this down and use 1, 2, and 3, then what should we get? We get C#, then we get actually nothing technically because it's a space character, and then the third character, which is the fourth in the list because it's 0 based, is going to be our I. So let's just print this out to the screen and see what happens. There we go. So even though we don't see it visually, there's actually a space character right there. And that's the third character in the list, which is right here. So of course we don't tend to know how long the string is unless we can see it visually. And if you were to reference one of these values and the string is not actually that long, then you have a problem. Let's demonstrate. If we have the string just called C# and let's comment out the rest, then that's only 2 characters, so only 0 and 1 will be applicable. These two will return back something. Let's have a look and see what happens. So the first character and the second character will run fine, and let's put a console read line in there just to break it up so the other code doesn't run yet. If we run the code, we get our C#, and that's the max length of our string so far. It's 0 and 1. Now if we press enter, let's see what happens. We get an index out of range exception. Index was outside the bounds of the array. And the reason for that is we only have 2 characters inside our message and we're trying to display the third and the fourth. This is problematic because we literally don't have any of them characters to display. So what we can do instead is actually write ourselves a little loop to go through the entire string and return us back all of these character positions instead of us just guessing how long the string is. So if we return this string back to normal, and then just after this little section, we can write a for loop. Int I equals 0, and I is less than message, and then we have access to dot length. This gets the number of characters in the current string, so we don't have to worry about the maximum length in the square brackets. We can always rely on dot length because we don't have to keep track of it, and the language can know that for us and give us the value. In this case, we're going from 0 to whatever the length of these characters are. And then in here, we can actually just console write line, and we can do the same notation we did here. We're saying we want to print the message, but not only the message, we want to print the index. And the index is going to be I in this case, because we start at 0 since it's 0 based, and then we're going to the last character. So let's print this and see what happens. So now we get C# is awesome from here down to the bottom. C# is awesome, print on every single line, and that's a little bit annoying to read. So what we could do is just change this to a console write, and maybe we can just comment this section out just so we can see this properly. There we go, so we get C# is awesome, and because it's a console write, it's writing them all next to each other, and they're being printed out one by one. Let's add a cool little effect that can demonstrate you for now. So inside the system.threading library, we have this sleep function. So what we can do is we can add another using command, system.threading. We already have threading.tasks in there, but the function that we need is inside the threading library. So there's 2 ways we can write this. We can actually write everything by hand like this, .sleep, or you could just remove the system.threading because we've added it at the top. If you don't want to add it at the top, that's not really a problem. You can just include it straight into here. Adding it at the top will include it within the entire project, but if you're only going to use it once or twice, then sometimes it's better to just include it straight into here, because it'll make your overall program size a lot smaller. So let's just keep it in so we can make our code a bit more readable. So we have thread.sleep, and what this will do is it will suspend the current thread for a specified number of milliseconds. There's 1000 milliseconds in 1 second, so what we can do in here, and we're trying to mimic a typewriter effect, so we can say something like 200, which will be roughly a quarter of a second. So if we run the code now, let's see what happens. So we get this cool effect where after it prints out each of the characters, it will print out the next character only after it's been asleep for a quarter of a second. And that looks kind of cool. If you wanted to speed it up, you could just decrease this number. There you go. Of course, if you make it too low, then it might be too fast for you to actually acknowledge what's happening. And if you also make it too slow, then it's just going to take too long to turn off, and at that point you can use Ctrl+C on your keyboard or use the stop button at the top to terminate the program. Okay, so let's have a look at another thing that we can do with this. So maybe we can make this 100 for now. In the previous videos, we've used a function called contains. And let's say we're just checking if it contains C, and we know it does because we can see it visually. Let's run the code, and we see we have true being printed. And the reason why true is actually on the same line as C# is awesome is because we're using console.write here, so it's actually not made a new line character just after the E, so when it's printing true, it prints it straight after that. So what we can do to fix that is just place a new line character in here using console.readline, and we can just drop this a little bit lower to 50. There we go. So we have true. And what we can do with this is we can actually make our own little version of the contains function. Let's demonstrate. So if we make this exact for loop again, int I equals 0, I is less than the message.length, and I++. So first let's kind of understand what's going on with this function. Returns a value indicating whether a specified substring occurs within this string. And what that means is it will return a boolean for us. If C is inside our message, then this will return back true. And we know this is true because we just outputted it to the screen and we can see this visually. So what we need to do is we need to loop through our message and try and figure out if we can find C inside our message, and then we can give back a value of true. So maybe we can do a bool contains equal false. And the reason why we initialize it to false is because